Good morning, friends. I am thrilled and honored to stand before you here today as we gather for DebCon 2023. DebCon has become a cornerstone of our community, a place where innovation, collaboration, and the pursuit of knowledge converge here on the bank of the River Spree during Berlin Blockchain Week. Each year, this conference serves as a testament to the remarkable progress this ecosystem has made in the year past. It is a moment when we come together to exchange ideas, share insights, and push the boundaries of what is possible in our rapidly evolving ecosystem. This conference has always had a dual focus, so infrastructure and dApps. And while we have made enormous strides in the infrastructure arena over the last couple of years, I expect the coming years to be squarely in the sign of decentralized applications. Let's leverage this technology we have built over the last years as puzzle pieces to build dApps that are not only usable, but offer genuinely better user experience than their Web 2 equivalents. We have embarked on doing that with Gnosis Pay and Gnosis Wallet, which I am sure you will hear about during this conference as well. And you can also find us at the Gnosis booth, so happy to talk about these. But there's, of course, also plenty of other people here. And as we embark on this journey together over the next few days, we have a remarkable lineup of speakers, workshops, and networking opportunities. We'll delve into cutting-edge topics, explore emerging trends, and engage in hands-on experiences that will empower you to drive change and shape the future. DebCon is more than a series of presentations and sessions. It's a convergence of minds, a melting pot of ideas, and a place where connections are forged. I encourage each and every one of you to actively participate, ask questions, challenge assumptions, and most importantly, share your insights and experiences. Few housekeeping things before I make way for the first actual talk. If you've been here before, you know that our stage 2 has traditionally been on a boat. Sounds awesome, it's pretty awesome, but to the surprise of everyone involved, the boat has been denied permission to anchor just a few days ago. So we have no idea why. No one has any idea. Apparently it's never happened before. So some frantic replanning had to happen. And stage 2 is now on the 5th floor, Studio A. There are 2 elevators and 2 staircases to get you up and down. Follow the signage. Our sponsors are located out here in the main hall. They are fantastic. Go check them out. They still have socks. The co-working areas on floor 4, Studio C. Food and drink and smoothie trucks for lunch will be placed outside by the River Spree, like the last years. And there are coffee and drinks carts throughout the venue. Today, there is a happy hour after the scheduled program. It starts at 6 p.m. Out back by the Spree. And the after party on Wednesday will take place at a true Berlin cult classic, the Prince Charles Club. So see you there for sure. And last but not least, a big shout out to our sponsors. Thank you for making DebCon possible, and an equally big thanks to Marin and Leander, who had the DebCon team, and their team of awesome volunteers. Thank you for putting together this conference once more. And to all of you, thank you for coming. Let's make this year unforgettable, and welcome.
Hello, everyone. Good morning, and welcome to DAppCon 2023 in Berlin. I'd like you to put your hands together for being here so early, if you can. Please let's put your hands together. All right, so I will be your moderator for this morning, introducing all the speakers. And we have Hsuanting.eth from Furucombo, who will be talking to us about the opportunities, risks, and our observations with the intent-based architecture over the years. So if you could please just kindly join me in putting your hands together as we welcome Hsuanting.eth from Furucombo. Thank you very much.
Good morning, everyone. I want to introduce about me first, and then talk about what we're going to talk today. So about me, my name is Hsuanting. I come from Taiwan. I am the co-founder of Dingo, and we started to build decentralized apps starting from the end of 2007. So we started from like Dingo DEX, it's older book style decentralized exchange, which is not so sexy anymore. And the famous product that we built is Furucombo.app, and now we have built a protocol link. So today I'm going to share the topic about like opportunities, risk, and our observation with the intent-based architect over the years. I can say intent is the buzzword like within a couple months. Everyone wants to know what is intent, so do I, but no one really understands what is intent. So I'm just like sharing what we think about this. It's not a firm answer, or it's not there yet, so just some thoughts about this. So like if we search what is intent on the Google, or start to see at the community, how people describe intent-based architect. What is intent? Some people say, okay, it's a better user experience, easier for people to use. It might be the solution to onboard the next million user. Some people say it's a shortcut. We don't have to deal with a lot of different things. And some people say, yeah, intent is just basically DEX aggregator. I'll say this is all correct. And we take the cow swap, for example. They are the intent OG, personal opinion. You go to cow swap, and then you express your intent on their site. Say, I have ETH, I want maximum USDC. So you can feel like, oh, I'm already in the intent like now, like every day for the couple months or year. So you submit your intent to CowSwap, and then the solver or the protocol, they are start to work on finding you the best solution to find a co-instance, or they can go out to the DEX to ask for the best price, best route, and then put it on chain. So this is very classic, or the intent architect that we are using now. But intent is not just focusing on DEX or token swaps. You can say any other like DeFi actions or a lot of different things, they can be intent. You can express your intent. So let's take Furucombo as an example. If you want to do a collateral swap on Aave, you can go to Furucombo, and then you express what do you want to do. It's basically you put every step, and then you made your own solution. So it's very complicated, but it works. And we see people that is getting really, really confused on how can I swap my collateral from USDC to DAI in a very efficient way, instead of just go to Aave.com or Uniswap.org to back and forth, or even Furucombo is a little bit complicated in it before. So that's why we have the landing dashboard. So the landing dashboard is to shorten the journey of swapping your collateral or any DeFi actions. So you just tell us that you have USDC as a collateral, and then you want to go to DAI, and then we do the rest for you. So you can say this is somehow like an intent, but I won't say this is the classic one. So if we give like short summary about like what is intent, I'll say it's a process to express what you have and what you want. You have ETH, you want maximum USDC. But you don't have to worry about like which DEX you should go or which trading route you should go. You just leave the rest to professional to explore the possible solutions. So this is intent architect, personal opinion. But if you want to see, what's the stack inside the intent architect, what can we do if we want to build something, what should be the focus? I would say it's account abstraction, automation, MEV, and privacy. So intent is not just for like DeFi, swaps, lending. I think it can expand it to a lot of different things, like bridging, farming, even perpetual trading, this kind of like really, really complicated. And then you might think that, oh, there might be a better solution than my solution. Then you can use intent, let the solver, let the professional to find the best for you. Also, NFT trading is even more complicated than token swap. It contains more information, the market is more complicated, so I think NFT trading is like super good case for intent trading, intent architect. Also gaming. I would say basically everything happen on chain is suitable for intent. Just like imagine in our real life, if you don't have time, or you are not the expert of that area, what you will do, you will find an agent to buy the house, to plan a trip, or to do anything you want. So I'll say everything you can include it in an intent architect. So if we know that, okay, intent is coming, intent can cover a lot of things, but what will be the change for the user, for the builder, for every one of us? I would say first thing is if the intent is coming or we have more intent architect, for the user, it will be easier to navigation. That, of course, everyone here, we know if we want to swap a token, where should we go? And then what are the bad decks? What are the good decks? But for our parents, for our next generation, might not be the same. Just imagine easily if someone, a friend of you, you say, oh, you can swap your token, blah, 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 and then they'll start to process like, oh, where should I go to find the best exchange? What should I prepare? And then do I need to know anything? So if we can just simply say, hey, I have ETH, I want the USDC, and then throw it to the intent, to the solver, and then they'll help you to done. So you'd have to know who's the DEX, like, or should I go lending first and then DEX or something like this. So it's easier navigation for all the users. So that's why people will say intent architect can bring the next million user to the crypto because we somehow make it easier for them to do things on chain. And also related to the user, it's a lower chance of being scammed. Like for normal people, who knows that it's uniswap.com or uniswap.org? Is it sushi.com or sushi.org? Or which contract I should interact with? Should I approve first or should I send out a transaction? What's the difference between sign and a transaction? A lot of knowledge they need to know to prevent them being scammed or make the right transaction. So same, I think solver or the intent-centric, that will help the user to stay away a little bit from the scam. And also DeFi can be operated on a mobile phone. Let's say if you want to do a collateral swap on your phone, is it possible? Yeah, it's possible, but it's really, really hard. You need to find a wallet that has an in-app browser and then go to the website, do everything by yourself. But what if you can just express what you want by using a Telegram bot or just like chatting with the ChatGPT, say, oh, change my collateral from USDC to DAI on Aave, and then they do the rest for you. That would be super easy. Just type and then send it out. Or even you can say, even long term, I have 30K US dollar. Make sure the APY is higher than a 2.5%. Then the solver, the bots, they keep looking for the higher APY for you. Keep moving your assets. Make sure it's doing well. So you can do it on phone. You don't have to check every day. You can even when you are taking bus, taking Uber, you can have this kind of command. So it's like super easy. And in the past, we will think, oh, if I want to do a trade, I can go to the Uniswap, I can go to the site directly, so that will save me gas, and then I can get a best price. But now, DeFi is getting more and more complicated. At the front end, you got tons of solutions. At the back end, you have MEV, you have sandwich attack. So maybe in the future, to submit your transaction or to leave your action to the solver, to the professional, you will get better result compared to your own solution. And there are a lot of vaults on the internet, not on the internet, on the Web3, like Yearn or blah, 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 a lot of vaults, DeFi aggregator. So I think maybe the vaults will be replaced by the solver bots. You just like, oh, I have 30K US dollar, and then find me the best solution, keep finding, keep moving. So I don't have to deposit into a predefined vaults. Yeah, the vaults are good. All the rules are there, so you don't have to worry about their being bad. But yeah, solver will be more flexible, and then they can consider based on the latest trend. Maybe just a new protocol goes online last night, but vaults cannot update that quickly. So maybe we're replaced by the bots. And anything outside the core business can be handed over to the solver. I'm saying that, let's say you are building a protocol, lending protocol. You want as much as people deposit their asset to your site, right? I have $30K US, but I want to put my USDC to ETH as a collateral because ETH got higher APY assumption. So I have to go to DEX aggregator and swap my USDC to ETH and then come back here. What if a dApp, they can just simply say, oh, I integrate with some API that can automatically swap whatever the user have to the target, like ETH or USDC as a collateral and put it on my platform. If you want to do this, it's doable now, but you have to go to DEX and then hold the contract and then do the integration by yourself. And then you will have to maintain to their latest version. Smart contract changes fast, and then if you don't change, it might break or it might be danger. So you can leave it to solver. Say, hey, I integrate your API, and then what our user have, and then swap it to ETH, and then put it on our side. So you just focus on the core business. The rest will be taken care of by the solver. Also the bridge or fiat on ramp. Yeah. So yeah, every site they have a bridge, they have a swap, something like that. And maybe dApp don't need a front end anymore, since we are talking about intent, and then user might just interact with the solver or like CowSwap or that kind of thing. They will just say, oh, I have ETH, I want USDC. So they might not come to your site. So maybe you don't need to spend time building a website for the end user. Just focusing on catching those users who's go through the intent solver, and then they will communicate with your protocol directly. Yeah. So we see this trend. That's why we built Protocol Link. I'm not going to show the product the whole time, but just explain how this will help the developer to get into the intent architect. So in the past, we built the Furucombo. Furucombo is basically a DeFi aggregator. We connect it to major DeFi protocols on major blockchains. When a user they want to do something, lend out the collateral, lend out their ETH or swap token, add liquidity, blah blah blah, any kinds of DeFi action, they come to Furucombo, and then we give them solution. You can use this cube, you can use this protocol, and then they assemble their trading strategy and then put it on chain. So this sounds familiar, right? It's what solver is doing. They find the solution and then they put it on chain. Just in the past, Furucombo is focusing on the end user. We allow end user to do that. But now we have intent architects. So that's why we think maybe we should allow the bots, the solver, the developer to communicate with the dApps directly, just like the user use Furucombo to do that. So we redesigned the Furucombo backend and then make it standalone. It's called Protocol Link. So that means Protocol Link together. If you come to Protocol Link, and then you can find tons of different integration between major DeFi protocol and something like that. But the biggest difference is that in the past, Furucombo used smart contract to integrate with every protocol. So that is expensive, it's high risk, and costs us a lot of resource to make sure it's stable and safe. But now on Protocol Link, we used TypeScript, and then of course we still have some smart contract, but it's our core. We use smart contract. The rest, when we are communicating with other protocol, we use TypeScript. So it's easier for us and also the developer to maintain the integration between our engine and then their protocol. So let's see. CowSwap, you go to CowSwap and then you express your intent. I have ETH, I want maximum USDC, and then the CowSwap protocol do the magic for you. On Protocol Link, it's basically the same. We are not a solver, but we are a solution that we provide tons of solution to no matter it's a provider, developer, or the solver. So user express their intent or what they want to do. Simply, maybe you can say, I want to swap a token, and then through our API. And then our engine will start to check, okay, in our database, we got maybe 60, 600, or 6,000 protocol integrate with us. I can keep asking price to every protocol, and then, oh, I found the best price, and then, oh, I'm going to use you. So if you want your protocol to be seen by bots, by solver, by developers, I think Protocol Link, it's a good platform that you should integrate with, and simply just write the TypeScript. We call it logic, and then put it on our GitHub, and then your dApp will be have more, get a chance to get traffic from the bots, the solver, or other developer. But not just intent. If you are a developer that you want to build something on DeFi, but you don't want to write smart contract, or you don't know how to write smart contract, I think Proling is the best tool for you, because you just need to use our API or SDK, and then you can interact with the whole DeFi space without writing smart contract, which is very expensive and dangerous. So, So if you're interested, go to docs.proling.com. So, okay, I'm going to speed up, 5 minutes left. So what's the benefit for everyone if we are moving to intent architect, or more and more intent architect coming out? So for the user, it will be easier navigation in a crypto space. They don't need to identify everything. They don't have to go to DeFi Llama and try to figure out what is the right information. And also, they will get the best solution provided by the global agent, ruled by the math. Imagine, let's say, okay, I'm a Taiwanese, and I live in Taiwan most of my time. Maybe I have some money saved in Taiwan, so my bank will have an agent selling me what financial product I should buy to increase my wealth. But I would say, why the slides are moving themselves? Okay, yeah. So maybe my agent they are professional, but they are just maybe Asia focused. So there's USA or Europe. No one is genius about the global product. But if we are going intent, and then those solvers, those bots, they are global, and then they move fast, just like ChatGPT. So they can probably find you the best solution for you, and then it's just like Ethereum, it's ruled by math and science and cryptography. So I think that would be best. And for the builder, your dApp will have a higher chance to be known. In the past, you have to build front end, back end, and then run your social media, try to let people know who you are, what you are building. But in the future, maybe you don't really need to have a front end. You just focus on your algorithm, and then let the bots, the solver, find you and then use you. So I think that's a benefit for everyone. So what are the opportunities if you want to work on intent-centric stuff, intent-based architect? As I say, account abstraction, automation, MVV, privacy, anything related, I think it's part of this. And because everyone, that's it. Oh, if you want to go to CowSwap, I want to swap ETH to USDC, then it's using their language or using their format to do that. But if we want to make this global and everyone can solve my problem, everyone can read my problem, we need to have a language that, or regular expression of everyone's intent. Make sure it's readable by all the bots. And also, we got the solver. So solver, somehow from my perspective, is somehow like a node, or try to. If we can decentralize the solver network, and we can get the best solution without doing bad thing or good thing. So we need rewards and penalties on solver networks. And a more user-friendly entry point for the general user. In the past, we have to go to website using our browser, install MetaMask on it, and then try to submit a transaction. But maybe in the future, we will not use the browser to visit the dApp, or we'll use the Telegram bot, ChatGPT, or maybe just simply send a text or call by phone, talk to a like press 1 if you want to swap, press 2 if you want to lend money, something like this. So we can explore more entry point. And then more interactions, not just DeFi, like NFT, or real voting, anything on-chain. I think it's perfect for intent. And of course, privacy. I don't need to spend time talking about this. Everyone has already know the importance of the privacy. So the future. So I think the future was simply, if we can see, so let's say I'm sending a USDC to someone using Ethereum. I feel comfortable because I know how I'm going to operate this, and then I know the whole process, how it looks like, and then how to make sure that it's firm. Okay, maybe wait for 6 confirmation, 10 confirmation, and then I'm sure that, oh, okay, this person will get their USDC. But Intel architect is new. Like solver is still new. If we can, but solver, you can see the benefit of using them, and everyone's lazy. So I'll say solver will be the future. automatic slide. So the future. Yeah, I hope when we are using the solver, no matter it's a solver network or blah, blah, blah like this, we can feel very safe, very confident on, telling the solver that what I want, what I have, what I want, and then they will give me a solution. I will not get wrecked. It will be much different from now, because now if you want to do anything, you have to find your own solution. You need to understand the bridge, you understand all the DeFi protocols. Yeah, so this is the sharing of today on what we've been building and then how we see the intent. And this is my Twitter account. We call it X, but I still like the blue bird, so I still call it Twitter. And so there's a talk today talking about intent, maybe in the afternoon, might be good, so you should listen. So I think intent is something new. We want to gather a meetup or people who are interested in this, just chat. Nothing formal, just chat. And then maybe Wednesday, Thursday, or Friday. So if you want to know when's the time, I haven't decided yet. So you can contact us on Twitter. Yeah, that's it. So it's a question time. Any questions?
All right. Do we have any intent-based questions? We have people on the side who are willing to take questions. We have just a few minutes, so I will pick and choose. But we have a long list of talks today, so feel free to always ask questions. If you could just signify by raising your hands. I don't seem to see. Okay, yes. We have two.
Hi, thank you. Yeah, with all this new progress on intent-based transactions and protocols, I was just wondering if you were aware of any projects aggregating all this information of for example, for DEXs, like an aggregator, because it seems like this might be fragmenting liquidity again, while it would be great if all of this could be connected with each other.
So you are saying that is there anyone who's aggregating all the information, like on-chain information, like APY, rates?
Well, for example, yesterday at SafeCon there was a talk from Enso Finance, who might be doing something similar. I was just wondering if you were aware of other people working on something like this. Who are the people that are collaborating on pushing this forward?
Yeah, I think both ProtoLink and Enso, we are doing similar things, and then our API will provide information that it's calculated by us. And DeFi Lemma, I believe that they do provide some information. And also, if you are using Zeller and SDK, I'm not sure they keep updating it yet, but they do provide information in the past. Yeah. So, and I do agree that information is important. Yeah.
Awesome. We have the gentleman in front. Hello.
Here.
Gentleman in front. Anyone has any more questions? All right. I see the gentleman at the back, and also.
Hi, good morning. Thanks for the nice talk. I love to see the next 1 million users jumping on with a much more user-adoptable practice like this. How do you see security and trust on that end? Because obviously now we are trusting the solvers a lot more, which also could kind of give a centralization in the market again, because a faulty website is not as bad as a faulty solver, let's say.
Yeah, agree. And I do believe that it's a very important process, and to try to, because right now the solver is run by private company, and then just Web2 servers. So if there's one day we can see they find a decentralized way to do it, I think that will be that will be great, and then it will be a even a big thing, like compared to, like layer 2 or something like that, there might be another network, or there might be a standalone chain, just like, I think Flashbot, they are doing the same thing, a chain that is focusing on this, and then try to prove that if you handle your transaction to me, we will not do bad because we have this protocol, we have this mechanism, we have this node, something like this. Yeah, so I think we will see that in the near future. Yeah, that would be great for the user to use.
Okay, we'll just take the last 2 questions, and that would be. First? Yes.
Okay, thank you. Maybe lending into the privacy question, like optimization problems, they really do fall into like really heavy computation for a lot of them. So has there been any exploration around edge compute and in essence over like large data sets for these optimizations? Is that in your roadmap?
Can you repeat the question again?
Are you familiar with like the concept of edge computation?
No, sorry.
Okay, the idea that you can send compute to data instead of sending data to compute. And these optimization algorithms are really heavy. So is there this idea that you can basically craft a compute job for these solvers and then say, hey, can you run this algorithm against your data? And then the solver can come back with the answer to that algorithm in a sense. I know if I'm familiar, it's probably answered the question there, but yeah. Things like Filecoin, they have like huge data sets online. And you can't pull 10 petabytes of data, but you can send a compute job to 10 petabytes. And when you have all this data in one spot, you might be easier to send a program that you know is going to be executed than just trusting that the solver is going to execute the one you want. But I think that answered my question. So.
Okay.
Thank you.
Final question, the gentleman at the back.
So is there a plan for, like an ongoing plan for Furucombo? Is that something that you're still going to support and kind of continue to integrate, or are you kind of deprecating that product?
Could you repeat, please?
So Furucombo, are you guys going to be continuing to support Furucombo and continuing to integrate it, or are you going to kind of deprecate that product?
We are still like updating it. Just we have spent more time on building the prolink. This is the backend of the Furucombo. So once the Furucombo backend is like replaced to the protocol link, the speed of like integrating more new protocol will be a lot easier for us and also the developer.
Perfect. Thanks.
Okay. Thank you so much.
Thank you.
Thank you so much, everyone.
Sagt, dass jetzt nochmal anders Pause ist, ja?
All right, everyone. The next talk is going to be at 10:40, so we have a quick 5-minute stretch coffee break. So feel free to still stay in your seats or go out and grab a coffee. Thank you. All right, everyone, welcome back. So the next speaker is Julio Santos from Fractal, and he will be talking to us about introducing the IdOS, the self-sovereign identity layer of Web3. So if you can, please put your hands together as I welcome Julio to the stage.
Hi, everyone. Good morning. It's very good to be here. My name is Julio. I'm a CTO and co-founder at Fractal ID. And we've helped hundreds of companies and projects in the blockchain space over the past 5+ years work on identity verification. And I was here on DAppCon last year talking about what that meant for us, how we saw our product. I talked about the importance of not being an identity maximalist and of delivering identity solutions that folks using Web3 today need. And I talked at the time about the spectrum of products that Fractal ID offers, but I'm here today to talk to you about like the next level of that. And that's the IdOS. It's the identity operating system. And it is born out of a very pragmatic approach to how folks in this industry like to use identity. Because this industry is unlike any other, as you know. We've got a very particular ethos, we've got a very particular tech stack, and we've got a very particular type of user. And identity verification is something that is extremely messy. Identity itself is something that is extremely messy. And to do it well, you're very often working with regulatory compliance, which is also extremely messy. And you're very often working with supporting users, which is also extremely messy. And so, even though we've seen a number of solutions emerge over the years, we've always seen folks stay away from the actual hard work of identity verification. So we've built a lot of technically impressive deserts that don't really meet the needs of the market as it is today. And so the IdOS is born out of that insight that we have, the experience that we've built, but it is not just built by us. So I'm very excited about this still. This is still being built. We're launching it in November. And it was hard for me to fit slides into 20 minutes because there's so many trade-offs that go into building this thing. And I really like to talk about them all, but, well, we can't. So instead, what I'm going to do is I'm going to give you a brief introduction of what this is and why we're building it. And I'll show you a few of the technical details about how it works under the hood. So the IdOS is a chain-agnostic protocol for self-sovereign data management. And we will see what that means in practice, but the TLDR is your keys, your data. And the chain-agnostic part is critical because, well, I mean, Web3 isn't just Ethereum or just Gnosis or just Solana, right? And folks use dApps wherever they are. They're not going to know where they are soon enough anyway. And so we need a solution that works for everyone, everywhere. And that's why we have such an odd collection of building partners for this that we're looking to expand in the short term. If you're building an identity, do please reach out. And that is because, like, even though we've been doing this for a while, we can't do this alone. This is something that we're trying to build as a common good for all of the space. And we need good partners with good use cases and good perspective and alignment with us on identity to push this forward. And so Quill is a strong technical partner that we have that built the underlying data storage that I'm going to show you in a little bit. Near has a very, very keen focus on adoption and user onboarding that we can relate to very, very much. They're very pragmatic in that sense as well. They're integrating the IdOS into their blockchain operating system for the Near.org gateway. We're working with Gnosis. As you've heard many times and you'll keep hearing, Gnosis Pay allows you to have a self-custodial Visit debit card, which is a highly regulated use case for which the IdOS is also very well suited. We're working with Aleph0, who is a very strong privacy team who are building a compliant version of Tornado Cash. Identity underpins all of these cases, and so we're helping everybody build this together. All right. There we go. So, I mean, if you're in this talk, you probably know a little bit about like why decentralized identity hasn't been done right yet, and why do we need it in the first place. And the fact is that most of our interactions have already moved online over the past couple of decades. What's getting increasingly harder, what is new, is how easy it is to confuse you with a bot, with an impersonator. This erodes trust. And that trust is required for, I don't know what's going on here, but that trust is required for human interaction and for us to be able to coordinate and thrive. And coordination is one of the core tenets of blockchain technology anyway. And so ignoring identity as a core part in that is something that, well, I don't agree with. And it's also very important that what we build here, just like everything that Fractal has been built so far before, is not something to show off a piece of tech, and it is a product that is used for actual people in the space with an actual user base. Now, why are we doing this personally, Fractal? Fractal is what in the decentralized identity context you would call an issuer and a tester. We do identity verification. And the reason that well, there's many reasons why we are doing this, but personally, one of my favorite ones is that I have to secure a database with over 1 million passwords. And first of all, I shouldn't have access to this database. This data shouldn't live with me. And second of all, this is a gigantic honeypot that we need to serve our customers, and I don't want to have it. And so the IdOS decentralizes the storage of this data and removes control from us. And we're going to see how that works in a little bit. But this shows an approximation of how Fractal would work today. We've got user accounts, we collect their data, verify their identity, and then folks that consume this have different options to integrate with us, whether or not they need the underlying data. But this has a number of problems, and well, we'll see that in a second. So what we're doing next is we're first launching the IdOS in parallel to our current system so that we can still later this year get rid of it. So this destroys the honeypot that now we have to secure and everybody else has to trust. And what's also cool about this is that we have no special privileges as Fractal. Again, we're a partner in building this, and any other tester, say a credit scorer, an identity verification company, whatever it might be, they can also use the IdOS with any requirements that we wouldn't have. So this is a level playing field for everybody, and we think that competition is going to be very healthy here. But the coolest part is that everything that we've built so far always relies on us being around and doing a good job forever. But what the IdOS does is allows Fractal to disappear. If we build an ecosystem where other people contribute data and information and insights, then we've built a common good that doesn't require us to be around, or folks to believe that we're going to be around. Now, this is great for users because your keys, your data. You are the only person in control of the data that is in your profile, and you can edit it, add to it, delete it, and you decide who you share it with. You do this without needing special tooling like identity wallets to carry your data around and requiring you to be present for every interaction. You don't need soulbound tokens to dox you on chain. You need the IdOS, and it's got a much better UI anyway. For dApps, this is good because they get a guarantee that they haven't been able to get before, which is their user data is stored in a compliant way, and it is stored in a way that allows for retrieval once the user is no longer in your dApp. And we're going to see how that works in a little bit, but something that we're really trying to make sure happens is that folks copy as little data as possible. And so if you need some information about a user or might need, get access to that data rather than the actual data, because this will, well, discourage duplication. And again, we're not the only ones playing here, so this is not a closed system. This is a public good. Now, the IdOS is as I said before, it's a network of decentralized storage nodes and an access control protocol. And for you to be able to pull data from the IdOS or read data, write data, whatever it is, you need a signature. And you can only read that. You're the only one that can read data that's associated with your wallet. And you're the only one that can write any data against the profile that is associated with your wallet. Once you have an IdOS profile, you can rotate that wallet. You can add 10 more. You are the signer. You are the only party that can get access to this. And through, say, the data dashboard that we're building, through any DApp integration that is building on us, and in general, just using our SDK, it's very, very easy to control the data that you've got stored against you. And to be able to, well, help other people get access to it. Access grants are a core part of the system where somebody can tell you, you can access this data tomorrow, and you don't need a signature from me to do it. Again, you authenticate with the IdOS with the signature, and I can pull my data, or I can let you pull my data tomorrow with your signature instead. You don't require me to be online. Don't duplicate if you don't have to. These access grants can optionally be configured with a time lock. This is something that I can tell you, hey, you can have access to data ID 42 that belongs to me, or you can have access to that for a whole year. And what that does is it prevents me from deleting the underlying data or deleting this access grant. This is particularly relevant for some AML KYC compliance use cases that I'm very familiar with, where many jurisdictions require that you still have access to the underlying data for 5 years. Again, this is entirely dependent on user consent. They don't have to give you the access grant. This is an option to bring the system into compliance. Right? Now, for dApps, they can also think about this, it's not just identity verification. It can be a whole backend for their data. Data privacy regulations and how you are supposed to store data that belongs to your users and the rights that you need to give them, I mean, they're not particularly complicated to implement, to be honest. Just don't be an asshole, do the right thing, put them in control, and it's going to be fine. But this is a minefield. And if you don't need to maintain your own backend, if you don't need to maintain your own database because the data lives with the user on their IdOS, it's, well, one less concern that you have. And it really helps them with things like data portability. And the data in the IdOS is stored, well, most of it, in the form of verifiable credentials. So this is it's an interoperable W3C standard that a lot of decentralized identity tooling knows how to consume and to operate with. And our tooling helps data be written in this form to facilitate portability and interoperability wherever we can. Now, let's look in detail about a couple of things of how this works internally. So decentralized storage is not done with IPFS or Ceramic or any solution that you might know, because while those are great as well, we wanted to go with something that more resembled the relational database, which is something that is a lot closer to the normal data workflows that we are used to using and developers are used to using. And so this system acts, instead of it being a file store, it acts as a relational database driven by SQL, as you will know. And this gives us some interesting affordances. So what does this database look like? This is an earlier iteration, but you should get the idea across. You having an IdOS profile means that you've got an entry in that humans table up there. And everything that is associated with your profile, attributes, wallets, and credentials, have a human ID, because this is a relational database. So the way we know if an attribute belongs to you, if you can read it, if you can modify it, or how you can add a new one, is by looking at wallets as signers that are related to the corresponding human. And that's how we determine ownership of own data. Now, because there's also data grants, grantees are also, sorry about that. Grantees are also like subject to access control here, obviously. And so when you ask the IdOS for your data, it checks, do you own this data because you've signed it correctly and it's associated with your wallet. Grantee works a little bit differently. So the IdOS, just in terms of internals a little bit, this is not code that you would have to write. This is how we define the read and write operations that the IdOS exposes, for example, through our SDK. And whenever you talk to it, your public key and then address are extracted, recovered from your signature. So there's this add caller variable that you can then use in later queries, as we're going to see. So say, for example, that you're trying to get somebody's credentials of a certain type, for example, KYC, and of a certain issuer, for example, Fractal. This is a very, very standard query to get that information, except we are joining it with the wallets table so that we can match that the caller, the signer of the message that was just received by the IdOS, indeed has access to the data that they're trying to get. Now, access grants have this, they're from a data owner to a grantee for a certain piece of data, and they include this optional time lock. And this changes the logic of what the IdOS does in the background a little bit. So to give you an example, like this is a simple interface in Solidity we've got several of these contracts because we need them deployed on the networks that people use for the wallets that they have installed. This is relatively trivial in terms of functionality. So you can only insert a grant for data that you own, so you have to be the grantee here, obviously. You can only delete a grant for data that you own as well, that is yours. For a grant that you created is something that only you can delete. And inside the IdOS node, instead of seeing, hey, who's signing this message trying to get this data, and matching internally in the relational structure, what we do is we check these contracts to see if there's still an active access grant that would give this new wallet access to this data. And time locks are enforced in the contracts and in the IdOS nodes by not letting you delete grants or data that are associated with something that you promised somebody would last until, say, next year. Now, the IdOS itself, the storage system doesn't really care what you store in there. And so if you're storing personal information or anything that is sensitive, then you need to make sure to encrypt it. And our tooling does that all by default. So all of the data that is stored in the IdOS in this database, anything that is sensitive, is something that not even node operators, the folks running these databases, should be able to access. And so the keys for decryption and encryption, they're generated privately in user land. We've got an enclave in our SDK that makes sure that data dashboards and dApps and anybody else integrating it can't get access to it, and that is how the user is able to do cryptographic operations on the data. So we take a password or a seed phrase from them, and we use a key derivation function in order to extract a key pair on ID 25519 to perform the encryption operations over this data so that, well, wallets don't really offer encryption interfaces that are very consistent these days. And so this way, we make sure that the user is in control of the password that they have. And again, this is done via the SDK that we have, which doesn't have to, right? You want to use the terminal, you want to have your keys under your full control inside your air-gapped machine, you do that. Gonna skip ahead of this. This is just more detail on the same. An interesting corollary of this is that when you're storing data in the IdOS, you need to be very careful not to encrypt things that you shouldn't. So if you're authenticated and authorized with your wallet address, if you create a new wallet and write it against your profile, if you encrypt that address, the database engine is going to have no idea how to match it. So there's guidelines about what should be and shouldn't be encrypted. Something that we're struggling with at the moment, and that I would love some input if anybody has any ideas, is how to prove that when I take a piece of data that was requested of me and I re-encrypt it with your key to create an access grant, to prove that I actually re-encrypted the right thing. We've got a few mechanisms around to kind of mitigate this issue when we were thinking of others. And of course, data can always be shared directly, but this is something that is not one of our core skills. So if anybody has any ideas, I would love to hear them. How can you build with this? Well, use our SDK. This is very, very trivial. We abstract a lot of the IdOS operations from you. You're essentially just going after reading and writing data, and our SDK will make sure that it is prepared for encryption with the user, it gets their password if it doesn't remember it, and it does all of those operations in the background. So you take a signer, like MetaMask, for example, you initialize the IdOS with that, and then you can perform straightforward operations like current user, like who is here right now, what's their IdOS profile. How do you get credentials from them? For you, this is one line. There's a lot happening in the background. The user will often have to sign a message, prove to the IdOS that they can get this data. It will need to be decrypted with the key derived from the user's password. The SDK deals with all of that. All you need to do is ask for credentials. You can create access grants based on objects that you have seen with the SDK or otherwise. And you can later get access to it very much like you would get access to a piece of user data, except it's you signing instead. How do you verify these credentials? Well, they're verifiable credentials for a reason, and our SDK helps you do that. And I am out of time. I was going to tell you about a couple of things that you could do with this, but I think that the examples are enough, and I will respect the clock. So thank you all very much. And if you folks have any questions, I'd really, really love to take them.
Awesome. Thank you very much. Because of time, we'll just take 2 questions. I can see the gentleman over there, and there's a gentleman in front here.
Thanks for the talk. You mentioned there is this enclave in the SDK that you like to generate this key. What could be attack vector on this enclave?
The browser, for one. So if you don't trust your browser could be leaking. They could be not implementing the W3C recommendations on iframe sandboxing, for example, and that could eventually leak to the DApp. There's other ways that we've thought of dealing with the user password and the key. We didn't want to build an extension to deal with that. It's something that we will, because there's going to be a subset of users that will prefer that additional layer of security. But so far, we haven't been able to break the iframe sandbox in any way. It's something that's been around for over a decade now, standardized, and so it's something that a DApp will not be able to get access to because of the cross-origin policy.
Yeah, thank you. And also, is there any computation layer, or you're leveraging something like TEE or compute data or similar things?
Not yet, no. That's the kind of service that we would love to see being built on top of this. So the credentials that we generate, some of them have selective disclosure capabilities. So you can disclose only a subset of the credential and maintain the proof. Zero-knowledge proofs on top of that would be a really interesting mechanism to create derived proofs from them. But on a level above, being able to use aggregate data to reach conclusions without actually inspect the underlying data is something that other folks have built already, and is something that I think is going to definitely be a very common use case of this. It's a bit of a next-level target for us, and we will likely work with partners towards making sure that that happens.
Thank you.
Well, thank you.
Good morning. Thank you very much. I understand the point that obviously you have a database underlying where you store the credentials and all the relevant traffic. You also said you have file storage.
No.
You don't have file storage.
No, so that was the decentralized database as opposed to traditional decentralized storage, which is file-based. So this is a relational database, something similar to SQLite, and with a consensus protocol to make sure that all of the database nodes reach consensus on data modification.
Okay, right. So that makes it clear, because I thought if you have data storage, that would be kind of defy the purpose, because you want to offer your service to all data storages. Okay, thank you.
All right. Thank you, everyone. Please let's put our hands together for Julio Santos again. Thank you.
Thank you, folks.
All right, everyone. For our next talk, we have Brenda Loya from Tellor. She will be talking to us about the best practices for Oracle's implementation. Please let's put our hands together as we welcome Brenda to the stage. Thank you.
Thank you so much. Hi, everybody. Who here is actually planning to eventually found your own project? You? Okay. Have you guys actually gone through the thought experiment of thinking, what will happen if I wake up one day, you go launch, you go live, you're being successful, and all of a sudden you get hacked? Like what happens that morning when you find out that people lost money, that everybody's upset with you and your protocol? If you haven't, do it. Hopefully it never happens, but this is one of the reasons why I'm doing this talk. I'm one of the co-founders of Tellor. Tellor is an Oracle. We've been live since 2019. Nothing has been perfect along the way, and it's actually my second startup. My first startup was actually Daxia. It was a decentralized derivatives protocol. And we launched that in 2018 with a centralized Oracle because there was really nothing available. Oracleized, that's not provable. It was basically the only thing that was available, and it's super centralized. So after about, I don't know, a year of being Daxia, we're like, okay, now we really have to focus on our Oracle implementation because it's obviously the weakest link in our design. And we couldn't find anything that was available, so we ended up developing Tellor for our own use case. And the one thing that was a non-negotiable was decentralization, so we knew it was going to be a little bit slower. But at the time, for decentralized derivatives, at least, we didn't need anything that was too fast. So we came out with our MVP. We ended up getting an investment for that, and now we're Tellor. But with that said, as you develop your own protocols, there's three main things that you need to keep in mind when you are actually using an Oracle. As a user, you have to be able to define the data that you need and define it in a way that is robust. The second thing that you have to look at is what Oracle or oracles and the implementation that you're going to do and include into your system, and do the evaluation based on what you need. And then the third thing is what are the backstops? If everything goes to hell with your Oracle, what happens to your users, to their money? How do you settle? Because those are three different parts of your design it's at the end of the day, they hack your protocol. It's going to be your fault, no matter whose fault it is. If you're the CEO, if you're the co-founder, it's going to be your fault. Anyway, so moving on to something happier. I'm sure this is a very technical conference, so I'm assuming everybody knows what the Oracle problem is. There's a lot of oracles out there. We all try to do the same thing, basically bring off-chain data on-chain. And now, more recently, there have been more talk about the Oracle-less DeFi and how basically you're trying to find price discovery on-chain. And honestly, I think that was the initial goal that we all had. It's like, you know what? Everything's going to be independent. It's going to be a completely separate system from what the traditional system offers. And then along came all of these centralized exchanges. And the moment that they basically list your token, so we have TRB, the moment Binance and Coinbase listed us, the majority of our liquidity, just everybody moved there. So now, even if you wanted to do price discovery on chain, it's harder because people just like the convenience, and they're great for onboarding people that are not as familiar with Web3 as some of us that are more technical. But it creates this disconnect. Like our original design was like, let's, everything's on chain, everything's going to be independent. We're going to be able to survive with or without the traditional system, and hopefully bring some competition so that they continue to serve their actual users and not, abuse or, charge extreme fees or whatever it is that we were trying to accomplish. But the whole goal was to have this whole ecosystem that was separate. And then ultimately, there is a lot of price discovery that you could do on-chain, but then honestly, depending on what you're building, that may not even be possible, so you might still need oracles, and even if it's not just for price discovery, maybe you're just doing a different type of query. So this is basically, this is a very, very basic example of how oracles are used on-chain. And like I said, we bring data that possibly you cannot really create on-chain, or data that just makes use cases a little bit more interesting. There's a lot of oracles out there. There's Tellor, Witnit, Band, Dia, Chainlink. We all work a little bit different, but ultimately we're just trying to bring off-chain data on-chain. And who is the best protocol to use on your system is going to depend on what you actually need. And a lot of people leave this to the end of their design because you're focused on your cool protocol, right? You're focused on what you want to build. And this is just one part of it. But ultimately, it's such a big part of security that you have to go through this thought experiment. Otherwise, you end up having unintended consequences. These are just 3 examples of things that have happened in the space that, 2 of these were not even malicious attacks. They were just, it just happened. Oops, how do I go back? Yeah. They just happened. Like Black Thursday had a lot of unintended consequences for Maker, right? Just because gas prices were so high and they couldn't get their Oracle to update fast enough. And then, Jesus, this is like trying to get me to move faster. And then the BCX hack was actually a malicious attack where they took a flash loan to manipulate the Oracle and then use Tornado Cash to sort of take the money and leave. And it was all in an atomic transaction. It was actually 2 hacks. So because they moved so quickly, they settled everything so quickly, there was no way, not even a fork could save them. Once the money is gone, the money's gone. And then synthetics, it wasn't really a hack either. That was actually they were using one single API for their price feed, and the API all of a sudden started reporting 3 extra zeros. And that led to a bunch of liquidations. Luckily, it was a bot, and they worked out with the bot owner, and they got most of the money back, if not everything. And so the first thing we're going to go through is I'm going to give you a framework as for when you're actually designing your own protocol, how to think about these 3 different aspects of your design. First one's going to be data definition. Obviously, no matter which oracle you end up using, you're going to have to tell them what it is that you need. And hopefully, they'll be willing to help you come up with a robust definition. How often do you need it? What sources do you need them from? And whether or not you want to actually specify the sources. And I'm going to go into that a little bit in the next slides. But, guys, this is... OK, and then what type of aggregation you may need, from different exchanges, volume-weighted averages. What is it that's going to make it harder to actually attack the actual asset? And then, obviously, if you're trying to secure billions of dollars with an asset with a really low market cap or very low liquidity and just listed in one exchange, that's probably not going to work. So you just have to think about those things when you're starting to define your data for any oracle. This is not, you haven't even decided which oracle you're going to use, but you do have to decide this no matter what. And obviously, if you do decide to provide specific APIs and a very specific calculation and aggregation for what you need, then you also have to think about what happens, what kind of outlier detection system do you want? Because what happens if an API comes down? What happens if the API, since you don't control it, they change what they're actually providing, or they happen to be testing something and report 3 extra zeros? And what happens if the API provider bans you from using it, or you reach rate limits with them? What happens if you don't actually get the data? And then also, like, in terms, if you are using an asset, because right now, let's be honest, most oracles, what we're providing on chain, it's some sort of pricing, pricing information. But if you are doing that, going back to like how can it actually be manipulated and what's the cost of it versus what it is that you're trying to secure is going to be super, super important. And then these are some of the ways that you can sort of mitigate the risk of this type of attack. If you do decide to provide specific API sources, you also have to be mindful that you're basically providing a target. You're providing an attack target, basically. And that's fine, especially if you don't have a lot of range for volatility within the information that you need, or if it's a very specific type of asset that is not listed everywhere. It's not like you're asking for the price of ETH or Bitcoin. I think more generally, that's going to have smaller margins, and no matter where people get this information from, it's probably going to be very close because it's so highly liquid and so broadly available. But that's something that you have to keep in mind. If you are using like CoinGecko or like some of these type of information APIs, they already do some of their own aggregation. So you need to understand how they actually work and what they actually include or can exclude, because it will affect you directly. Jesus. And then obviously, what type of aggregations do you want? Nobody should have ever used a spot price. That is something that in traditional system, there's plenty of literature of how you can define robust pricing mechanisms, because a spot price can easily be manipulated. It's just Ethereum or Bitcoin, or you don't really reach finality until like a few blocks later. And that's because it just makes it more expensive as time goes by to actually break a system for that much longer. It's one of the reasons Coinbase makes you wait 7 to 10 confirmations, right, before they actually say, like, yeah, you have that money and you can spend it. Now, in terms of the Oracle protocol, these are some of the, you have to evaluate them based on the characteristics that you need for your protocol to work properly. And that's going to be different based on whatever you're building. And I'll give you an example that I really liked from Rick Pardo from Liquidity. He actually went and did like this infographic that I'm going to show next, and went through like all of the different oracles, and based on what they needed and what they thought was important, then he went back and said, like, these are the trade-offs that I'm willing to make, and then this is the actual structure that we're actually going to use as our oracle. And I thought it was really, like, I have not seen anybody else do that, honestly, since 2018, actually. So it was pretty nice to see that people are actually thinking about this. When you're actually evaluating a protocol based on how they work now, you have to be very mindful of, like, you can, if they're upgradable, you can plan for every attack vector that they have at this moment, but if they're upgradable, and they change how they work, that can have an effect on your security. So that's something that you have to keep in mind, and you have to say, like, what is upgradable? How does it really have an effect in my security? What is their process? Do you have enough time to react? If it's going to take a year for them to like vote on it on a DAO, that's cool. Maybe you can react. You can do V3 and either take them out or address whatever it is you need to address so that you don't get hacked. Do they have an admin key or a multi-sig? What can they actually control, and does it really have an effect on your security? And then obviously liveness. What happens if they go away? What happens if you don't get any data? Like, what happens if the team gets sanctioned by the SEC or the CFTC? What happens to your protocol? This is the infographic that Rick came up with. I'm really sad they're not going to be using Tellor, but we never negotiate on decentralization, and so we are a little bit slower. But we are deploying Tellor layer next year, and that's going to allow us to reach consensus a lot faster. But this is basically his way of analyzing what oracle worked best for them, and I love it. I mean, everybody, the fact that he went specifically the things that they needed and what was acceptable, or what, basically those, the green, yellow, those color-coded, basically it's like, what are the things that I'm willing to trade off? Because there's no perfect oracle, but there are some things that you might be willing to do trade-offs on. Anyway, that's his Twitter. If you go there, he has a whole feed on it. The way that I've seen in the last few years people handle this type of risk is basically by implementing either multiple oracles and aggregating them on chain, or using fallback oracles. So when you use a multiple oracle structure, what you need to remember is that you cannot put all your eggs in one basket. Because if you choose 3 different oracles, they're going to have different attack vectors or different ways of working, which is great, because then for somebody to break your feed, they're going to have to pay a lot more money, right? Because now pay a lot more money, it's going to be more expensive, and it's going to be a little bit more technically difficult to achieve. But if you have all of the 3 oracles providing information from the same 3 APIs, and the API comes down, none of your oracles are going to work. No matter how, because then it's your data definition that is lacking. So it's like, don't put all your eggs in one basket. If you use different oracles, you vary your definition. They can overlap, but at a very minimum, use extra or different APIs so that if one oracle cannot get that information, then the other 2 can, or 5, or however many you decide to use. Then the other implementation that I've seen is using the fallback oracles, where because they want either something faster, they might implement one oracle as a primary, and then do triggers to fall back to a slower oracle, or to something that they believe would provide them some sort of liveness guarantee. So here, the trick is the triggers, because that's basically where the attack vectors can come in. So this is something that you have to really sit down and think about, because those triggers is that if you don't do them correctly, that's where the weaknesses can come in. And then within your protocol, so this is you just going through defining your data, providing a really robust definition that it makes it very, very expensive to manipulate the asset. Then looking into the oracles, determining what actually works for you. And then the third part of that is what happens if everything goes to hell? What kind of backstops am I going to actually implement within my design? What happens to your users' assets? And some of the things that we've actually seen in practice have been implementing a delay. Maker has a delay to use their oracle of 1 hour. You can freeze the system. I know Maker can freeze their system, and they did that when the whole Black Thursday happened. You can also limit the change of the asset within your protocol, or trigger a freeze based on maybe liquidations. But all of this you have to plan beforehand, obviously, before you launch. And limiting the asset, the change of an asset sounds like a good idea, because it can limit the losses, but it also limits the gains. And not all users are going to be thrilled about that. So be transparent. And then a fork. So a fork only works if you didn't actually settle and they didn't take the money into Tornado Cash and left. If they're able to do that, then you're out of luck. Not even a fork is gonna save you when that happens, right? So, but with a delay, let's say if you had a delay implemented where they cannot withdraw within, 7 days of some sort of dispute. Something that, it's 7 days of some sort of dispute. Then that gives you the ability to maybe fork, and as long as even if you don't have checkpoints included in your token, you can probably go back through events and to go and figure out their balances and sort of fork the bad actors out of the system. But all of this, you have to think before you launch, and it has to be part of your design for your own protocol, even though it has to do with the Oracle design or the Oracle implementation. Okay, I'm like, have 1 minute. This is basically a cheat sheet of, there's basically your protocol can be, or in terms of the Oracle, it can be, and the option vulnerabilities are going to be on your data source and your data definition. These are some of the ways that you can sort of mitigate the risk of that. And then for the on-chain oracles, obviously, evaluating them, taking the time to evaluate them before you implement them. And then the second thing is like, what kind of structure do you want to use? And whether, it's obviously, like I said, the goal will be like for every type of price discovery to happen on chain. That would be amazing. That, unfortunately, I think that for some use cases, it's going to be great. If for some use cases, it's going to be just impossible. And that's just for personal experience. I remember thinking, like, it was great. It was amazing when Coinbase and Binance listed us. But then it was like, wait a minute. Like, now there's, like, no liquidity outside of those exchanges. They have basically all of our, or the majority of our tokens. And that's great. But then now it kind of limits some things. And with that, I'm done. So I have, if you guys have any questions, happy to.
Hello, everyone. Yes, I can see the gentleman at the back.
Thanks for the talk. I think it was great. And we're designing a DeFi protocol, so very, very relevant. How do you balance security with lack of service interruption? What I mean is, let's say you use VWAP or TWAP to get aggregated prices, but then if the market moves and the volatility is too high, or if there is a flash crash, then people not going to be able to, execute transactions. So, like, what's the right balance there?
I think that's something that as a designer, that would be your balance, or the trade-off that you have to make, depending on what you're trying to use or how fast you want to make your protocol. But I cannot tell you it should be 50, like. I cannot give you a number because it shouldn't depend on us. It depends on you and what you think your users want and the risk profiles are. And I think as long as you're transparent with what they're actually getting into, it should be, whatever you decide should be fine. That's what's going to define the risk profile of your market. But I don't know that I can tell you, like, do it like this, and yeah. I mean, if you look at Rick's chart, like he's one of the biggest examples of like actually sitting down and going through the thought process of what they're willing to, or how they're willing to manage that risk. But then they decide what they want to do. So but look at that. Rick Pardo, I might be mispronouncing his last name, but he's from Liquidity. He has a whole, and I can give you, he also did a talk on it on the Blockchain Oracle Summit in Paris. And yeah, sorry, I can't give you a straight answer.
Okay, just take one more question at the back.
Hey, thanks. Great presentation. I just had a question on the part of like off-chain data and like making sure that you have multiple data sources. How precisely would you do that currently? Because most of the Oracle projects either don't tell you where the data comes from or don't give you the means to verify it. So if you use them, you don't know what's under the hood. So how do you make sure that it's more than one API, for instance?
Okay, so I know at least for Band and for us, you are able, as the user, you are able to provide a definition. And for Tellor, it's always publicly available because that's how we allow anybody to initiate disputes on the validity of the data. So the way that it works for Tellor is the definition is available on IPFS for everybody to know what to report and what is being reported. As the user, you will be like the owner of that data specification, and you get to decide what's in there. And that's where also you have to make this trade-off of like, if I provide specific APIs and specific aggregations, Then I'm also providing a honeypot or a vector of attack, but that's why you make it so robust that it will make it very, very expensive for somebody to go attack the asset. And then, or if you do it the opposite direction, where you're a lot more vague and don't give specific APIs, like you're just like the price of ETH USD, get it wherever you want to, then now people don't know what to be a target, what to attack. So then now it's, you're still going to get your price, but that also depends on the type of asset that you are using. Because if it has very, very small or low liquidity, and it's just listed in one exchange, or it's just on Uniswap, and the market cap's really low, then you're setting yourself up for a cap of security cap based on the value of that asset. And that's a trade-off that you do, at least like I said, for Tellor, for Witnet, for Band, you're able to specify what you want, or you're able to just say, like, I just want this. But you should be able to know what you're getting.
Thanks.
Yeah.
Awesome. Well, please let's put our hands together for Brenda. Thank you very much. We will take a break. We will take a break for 1 minute, and then I'll introduce the next speakers on stage. Thank you. All right, everyone. So we have Vijay and Andreas from Fileverse, who will be talking to us about trustless collaboration, the missing piece to a better web. Please let's put our hands together for Vijay and Andreas. Thank you.
Hello, everyone. Let's see if the slides will work. 1, 2, 1, 2. We're connecting our laptop, which is a bit different from the usual speaker format. Let's see. Waiting for a sign from God, which is a technical team. Okay, while we wait, maybe I'll start already. So hi, I'm Andreas. This is Vijay. We're two co-founders of Fileverse. We came here from the two corners of the world to tell you something very specific, and that's that the space is ready for non-financial applications at scale. So I know that everyone is quite hyper-focused, and for good reasons, on financial applications in crypto and Web3, but we want to start communicating the idea and build a narrative that non-financial applications are ready because of the stack that has been built for the past 10 years in our space. So this includes a bunch of important primitives. We'll cover those things. We'll talk a bit about the narrative and what drives our thinking behind that. And then we'll get into the nitty-gritty of the topic and talk about how difficult it is to build peer-to-peer applications at scale, try to explain what are the challenges people will face in doing so, but leave you on a hopeful note that the space is indeed ready for us to go into the type of applications you use every day online. So one of the main points behind the presentation that's going to be up any minute now is that most of the internet traffic today is on social media. If you go on SimilarWeb today, it's a website where you can compare the traffic that goes into different websites. You'll see that it's Facebook, TikTok, YouTube, Google, those types of companies and products that are the main ones that most of the internet traffic is directed towards. And we want to say that if we want the space to grow significantly and reach that holy grail of 1 billion users, the next billion users, we're going to need to be aware of this type of traffic and actually try to build applications that work that way. So I don't see any slides, so maybe we can go with the backup slides that were there originally. I see a change. OK, so even without the slides, it doesn't matter. I'm going to get into it. Hopefully, they're amazing. OK, maybe like that. OK, we can't move them, but already the title is there, which is very cool. It helps me at least cover the first point. The first point is that we're building for trustless collaboration. And this is important because it's not just a niche little problem of our space, it's something that can actually set us up for making the web more robust and a better place for us to have everyday online experiences. OK, so the next slide is just us presenting ourselves. It's quite important to know who is trying to tell you a little story or sell you something, so I want to show that we're not selling something. Vijay and I have been working on a project called Fileverse for 1.5 years now. We've been in the space since 2016. We're Gitcoin grantees. We've been on Gitcoin since since Gitcoin round 13. Represent, and we were for 3 rounds consecutively in the top projects behind DeFi Llama. It was quite encouraging because we saw that people were actually, yay, it works. OK, perfect. OK, it's a bit of the older slide, but let's go with that. So this is us. We're also Ethereum Foundation grantees. We've been working on smart contract recovery and social recovery for a few months now. Vijay is the co-organizer of SheBuilds.tech. It's the biggest non-mail focused Web3 hackathon in India. It's quite an amazing feat, especially if you realize the problem of diversity in our space. I'm completing my PhD in AI and cybersecurity at Oxford. Don't hold it against me. We've been in crypto for a long time, and we like running validators and nodes kind of all over the world. So let's get into it. We've been, I think one of the most important things that we're going to do right now in the talk, at least in the beginning, is tell you a bit about the pieces, the breakthroughs or some technologies that we're very hopeful for and that really allow us to build those technologies that that we call trustless collaboration. For those who were at SafeCon yesterday, you'll see that the talk is quite similar, although we'll go a bit more into the technical architecture towards the end and the challenges you can face in building those types of technologies. So, first thing that I would like to highlight is multisigs. Multisigs, we consider them as one of the most important breakthroughs of our space. It gave us this crazy concept that I'm still trying to communicate to people around me as a super important piece of technology that evolves, makes it possible for internet communities to be much more powerful and have material impact. So instead of just having a subreddit group, a group of friends on the internet, here you have people managing a bank account all together, even if they don't know each other, even if some of them are in India, the others in Nigeria, the others in Lebanon, the others in Tokyo. And this is incredibly powerful. The example of Constitution DAO is a good example. Another thing about multisigs is that it made our space more robust to compromise keys and phishing and all types of problems. Okay. Okay, yeah. Suite of account abstractions that come with Safe as well, and account recovery or smart contract recovery in case you lose your keys. Super important. It fixes a lot of UX problems that were quite detrimental to our space. The next slide is kind of where we're going with this conversation. It's about what if we could use those multisigs for something that was non-financial? What if we could use them for public and private or personal data? So you can think of communities trustlessly co-owning and managing content, files, a brand, an archive, a website, a digital garden. The possibilities are endless. And this is with security, with on-chain management of your data, which means what? Which means data and computational integrity. Now, non-financial applications in crypto, I know it's a blasphemy. People don't really like to talk about it for good reasons. It's difficult. But what are we observing when we take a look at the space? We see that there is a persistent point of centralization, which we don't like, that has remained unaddressed. And that's everyday collaboration and coordination is centralized. What does that mean? It means that our knowledge base, our documentation, our public content, the things that we share with our community and beyond for them to start understanding the space, build on the technologies that we've prepared, the protocols that we prepared, are just one arbitrary decision by one company or an employee going rogue or a bankruptcy or anything like that from actually having a collapse of our common knowledge base and wikis and all that. And this is catastrophic. Here I put two examples. I love both projects deeply. This is the Ethereum Foundation. This is the Gitcoin DAO. They're both using Notion to communicate essential information about their projects and facing the public and the audiences that they're targeting. It's a problem. You can't be dependent on a server in California if you're going to actually hope that your information is going to be available forever and for everyone and anywhere. I'm going to fast forward because we had some slides problem. This is not just a us problem, it's a problem for everyone on the web. Most adults around the world do not trust companies to handle their personal data. Most academics, political dissidents, journalists are constantly locked out from their workspaces, their collaboration spaces, and that's a huge issue. Those are some of my favorite websites: Reddit, Wikipedia, the Internet Archive. They're amazing examples of commons-based peer production, and yet they're all dependent on arbitrary decisions from the organizations that provide the tools that they have. Next slide. I don't know why it's going before I click. The community computers revolution. I'll stop in a bit and give the mic back to Vijay. This is one of my favorite terms. I think it really captures something that maybe blockchains don't, especially in elite little groups or in academia. People don't really like hearing the word blockchain or Gnosis or Ethereum. They get hostile immediately. And so I've been trying to use community computers as an alternative concept. It doesn't come from me. It comes from the Cosmos community, at least the first time I saw it, from Ethan Buchman especially, and he describes it as such. Personal computers unleashed unimaginable levels of sovereignty and interoperability for people, and community computers will do the same for groups. I deeply believe in this, and I think it is a great point. Now, almost done, community computers and the self-sovereignty stack. There's been a culmination of 10 years of blockchain and cryptography research and development, and those elements allow us to actually build what Sandeep yesterday called trustless applications instead of decentralized applications. I quite like the term, so we're going to use it here, and we're going to show you an example of that. The first crucial part of this is crypto wallets. We like to consider those things as a rebirth of public key cryptography. It gives hundreds of millions of people the ability to be aware of their public key and private key. It's very important because it's a type of adoption that PGP never achieved for a bunch of UX problems and more. Smart contracts, here I really like this quote I saw by Hudson Jameson on Twitter a few days ago. A replacement for intermediaries who would otherwise handle the logic or trust required in a valuable transaction or interaction between two or more entities. You have also content addressing by Arweave or IPFS, quite an important piece of technology as well that comes in this self-sovereignty stack and that merges amazingly well with community computers. What is it? No need to put your trust in where data resides. Trust is in the cryptographic identifiers of the data itself. So I like the point from Jay Graeber from Blue Sky that you're moving away from client-server architectures and you create what she calls user-generated authority. Final three things: multi-sigs and smart accounts, complexity reduction and a security increase, L2s and app chain, and social graphs, which give you basically the ability or the right to exit, which is primordial. Final slide, and then we get into the real business. New path for crypto adoption and internet freedom. Again, this is not just a us problem, it's something that will make the internet a better place. At least this is what we want to present today. And I think one way to think about it is as a new crypto on-ramp. What I mean by that is that we have the ability now with that stack that I described to cater for everyday online activities and interactions. Not only 3 Uniswap swaps a week with 2 NFT claims and maybe a Lens post. No, we're talking about I log onto my computer and my workspace, my collaboration, my file storage, everything that I do daily, it can be catered to a crypto stack. So what does that mean? It means that people would not be required to buy tokens or having tokens to interact with our space. This is super important. Why? It's important because we do not force anymore the new entrants into our space to abandon their privacy at the doorsteps of the first centralized exchange KYC process. This is a big problem that we currently all face. I'm a bit ashamed whenever I show to someone new that, hey, yeah, you first need to show your identity, then you need to connect to your bank account, then you need to show where you live, and you need to tell them how many times a day you go to the toilets, and you continue like that. It's a problem. This means that we'll not be locking out 90% of the world because space is either too expensive or requires a KYC process that is not possible for them. It also means that we can build technologies that are GDPR compliant rather than depending on monopolies to consider yes or no if they're going to comply by European Union regulations. And finally, we can build tools that your grandparents can actually use to improve their online experiences and explore the digital world. Quick demo. It probably won't work. It will not work, unfortunately, because of some technical issues. So we'll get into, okay, there are 2 missing slides as well, but Vijay will still manage to actually go through the architecture.
Okay. I think as devs, we all can imagine things when I explain, right? So I'll just perfectly summarize why we exist as Fileverse team and what we are trying to do, where do we fit into the whole grand scheme of things. I'm going to get into how we do it, meaning what is the tech stack and what is it that powers that thing we are talking about. And here in the demo, we were trying to show you how you could use Fileverse DApp through your safe account. It could be either using the modules or it could be either using the safe apps ecosystem that's there, right? So I'm going to explain the Trustless stack. Bear with me. no slides, so you'll have to work with me, right? So there are 3 components that are there. The first component is the client, meaning the website. Second component that we have is the smart contract. And third component that we have are the nodes, actually. The website is a statically built website, which we pin on RV or IPFS. The smart contract is the smart contract that's hosted on the chain, like it is, for example, a piece of code that's running natively on that. And then third thing we have is the nodes. So what these nodes help us is, like in multiple ways. Some places they help us store things. Some places they help us token gate things. Some places they help us coordinate message passing systems that we have built, right? And all of these nodes are open sourced on our repo. So you can go ahead and run them as well if you want to set up Fileverse from scratch for yourself using these nodes, right? Now, the interesting part about our architecture is not just basically the 3 components. What we use is also something called UCANs. UCANs is User Control Authorization Network. What does that mean? It means these are JWTs that are generated client-side and then used by servers for giving permissions or allowing someone to do something on that particular node, depending on what permission smart contract has granted to that person that is signing the tokens. Okay? And we also have end-to-end encrypted keys that are stored on the client. And then everything happens like without even needing any sort of server interaction with us, meaning our front end talks to the smart contract, and then smart contracts stores things for us. There is the reason why we are different from any other services that you might have used is like 2 parts, right? First is that we are not using servers to coordinate amongst the clients. Today, whenever you're using any app, what you do usually is you talk to a server, and that server allows you to either do something with that thing or not allows you to do something with that thing, right? It can be a website or anything that you're interacting with, Facebook, Instagram, or any of those things. So that is the server-client architecture. But instead of using that, we're going with like client, everyone that is helping us coordinate is a client, actually. And we use servers to facilitate those connections amongst those clients. If you want to get more understanding of it, I can share the slides after the talk. And the reason why this architecture is interesting, there are a few challenges that come with this new architecture that I'm talking about, like client-client architecture instead of using server-client architecture. The 3 things are like difficulty of building the right level, like how do you have the good decentralization with good UX, right? Whenever you are going after decentralization in your stack or onto your website or anything like that, the biggest problem that happens is the speed. You're actually trading speed with decentralization. If you involve more people to come to a consensus, they need more time, right? So that is a big problem that we are trying to solve. It's a tug of war between like what parts can we decentralize and what parts we can't, right? With respect to the UX into the picture. And the other thing is like how today, whatever collaboration infrastructure that we have, meaning like difficulty in extending the difficulty in extending the peer-to-peer infrastructure. So today, whatever like services, for example, CRDTs and all the servers, real-time collaboration infrastructure that you see is more inclined towards there being a server and all the clients talking to it with respect to the permissions and everything else, right? But in our case, that's not the thing. So we need to work on an RTC infrastructure that can work with the clients instead of just having a server that's coordinating amongst those clients, right? So that's one of the problems that we are trying to solve. All the services that we are using, like those are peer-to-peer services, are end-to-end encrypted, and that's the reason why we can be decentralized, more decentralized than a normal server, right? And yeah, the final thing is that local first is the next iteration of Fileverse, meaning because of our node type architecture or the way that we have implemented these nodes, you can actually run those nodes on your local system and then connect Fileverse's portal with it without needing to interact with any of our services. Even the domain names, you won't be needing them if you are using Fileverse portal in the next iteration. So yeah, in that, the big question is how do you protect privacy and maintain the high availability? Because whenever you are hosting something on the local, how do you make sure that that thing is available whenever the person needs? I think that's it. Any further questions that you have, feel free to ping me, and I'll share the slides because they have more details than what I explained. Yes.
Thank you very much. Let's just put that together. All right, so we will take questions. If anyone has a question, if you could just signify by raising your hands, and the microphone will come to you. Yes, the gentleman in front. OK.
I can come closer and listen.
No, sorry. Just 1 second. There's a question at the back.
Oh. Can you integrate Fileverse to a dApp and have some kind of private collaboration workspace that you can share with other people?
Yes. So the way that we are doing, the way that we have integrated Fileverse to the safe apps is by using, I think, iframe type architecture. We have just created it as a safe app. Same thing can be done, and you can integrate the entire website into your dApp if you want. And that would work out of the box if you follow the protocol of, for example, giving it right access related to the wallets, giving it all the permissions related to the signatures, and things like that. So yes, you can.
Yeah. OK. The gentleman in front.
Thank you. Kudos on the Gitcoin grants. I've been seeing you up in the charts. Basically, do you have any plans to treat self-sovereignty of the data? And if so, would you plan also to bring some computation, some access control, some monetization, and so on? And also, IPFS is pretty well-known standard for content storage. Do you see that being useful for you, or do you plan to integrate, or you think that this trustless collaboration system does not necessarily require this standard?
Yeah, great questions, great bunch of questions. So yes, there is already IPFS for content addressing and storage on Fileverse, but we like to give our users the option to do it locally, do it with Arweave, not even go through Fileverse if they want to pin their files. Basically, there is a default option not to overwhelm basic users, but for those who really care about their privacy or not being reliant on any intermediary, you can do that yourself. Computation, great question. It's something that is going to come. It's something where the space is not necessarily very mature yet, but there are some very interesting projects that are working on this issue. We're trying to help them out as well so that it can fit our specific use case. Computation, you said, IPFS, what else?
I mean, the access control self-sovereignty over the data.
Yeah. For access control, right now we're basing most of our architecture around the smart contract. It helps us do the access control and ensuring that this process does not break any cryptographic assumptions in the interactions between people. We use something that we call authority delegation. So we're using something from I think it's the Fission team, which is called UCANs, which is user control authorization networks. And it's an amazing piece of technology. It allows us to, without breaking end-to-end encryption, give temporary or permanent access from someone to someone else without necessarily sharing private keys. So this is very cool, and you have a whole new world of peer-to-peer interactions that opens up to you when you start using those things.
Thank you.
Thanks.
All right. In the absence of any further any more questions, please let's put our hands together for Vijay and Andreas. Thank you very much. Awesome. So we will be going on a lunch break. The halls will be shut. We'll be back here by 1:30 p.m. CET, so please head out to some lunch break snacks. My name is Sam from the SAFE team. It's nice to have you all here. Thank you.
All right. Welcome, everyone. I hope you've had a nice lunch, and we're going to get started here with a round of talks this afternoon. First up, we have Mona El-Issa from Avantgarde Finance. Mona is the CEO and founder of Avantgarde Finance, a scalable institutional-grade DeFi platform. So give a round of applause for Mona.
Thanks, John. You pronounced it perfectly. I know you were practicing backstage. So thank you, everyone, for joining us right after the lunch slot. And thanks very much to DAppCon for having us here. Today, I'm going to talk about driving mass adoption in DeFi. For those of you who don't know me, I founded Enzyme a few years ago in 2016, which was a decentralized asset management protocol. And after it decentralized, I founded Avantgarde Finance. And my team still performs some core development to Enzyme. But more recently, we also started an asset management arm. And we look after DAO treasuries, as well as having launched the first ever regulated and decentralized on-chain asset management platform. So I'm going to start off the presentation with a sort of bold, maybe daring claim, and say that I believe that DeFi is not as composable and interoperable as people like to say it is. I agree that it is composable with the rest of DeFi to an extent. But when you think about DeFi being composable with the rest of the world, I think we're just not there. So in today's presentation, I'm going to start off by telling you a little bit about the state of DeFi today and why I think it's not interoperable with the rest of the world by showcasing some examples. And then I'll tell you a little bit about the work we've done with Enzyme over the last few years to aggregate DeFi with DeFi. But recently, we've recognized that that's not enough. If we want to bring DeFi to the masses, we also have to think about the tools that we need to do that. So, see if this works. Yeah. So I think, when I think about the state of DeFi today, I think we've built brilliant micro solutions for micro problems in finance. So when you look at stablecoins, we've completely revolutionized the payments industry. When you look at protocols like Aave, Compound, Maker, we've completely changed how borrowing and lending is done. When you look at protocols like Kyber, 0x, Paraswap, we've completely revolutionized trading and made it peer-to-peer. And Uniswap, Curve, other protocols, similar, Balancer, have made it possible for anyone to become a market maker. But there's still an unsolved macro problem. So let's take a look at a few examples and see what I mean by that. If we consider a DAO treasury for a second, there's still no user-friendly tools for a DAO to contract an outside manager, a specialist, whilst keeping full custody of the assets and managing that manager on a day-to-day basis. It is possible if you're like a smart contract wizard, but the tools aren't there. The integrations that we need with Tally, Aragon, OpenZeppelin, and other DAO treasury management tools just do not exist today. There's also no easy way for a DAO to access off-chain assets if diversification, like in the true sense, is something that they desire. There's also no way for DAOs to track historical and current on-chain performance in 24/7 real time. We have the tools to do that in the asset management sphere of DeFi, but we haven't built the link to DAO treasury interfaces. And there are no sophisticated SDK and API which help automate strategies if that's something that a DAO wanted to do. Another example that I like to focus on is quant funds. So anyone who comes from the traditional world will know, traditional finance world will know that quants like to build their strategies in Python. And Python is largely incompatible with Web3 and DeFi today. There are no backtesting tools available for DeFi or DeFi and CeFi strategies, which are also very popular. And there are no tools to aggregate DeFi and CeFi behavior. By that, I mean, again, historical performance, financial metrics, etc. So that's my second example. And my last example is a fund administrator. So for those of you who don't know what a fund administrator is, quick like 10 seconds on that. Any hedge fund in CeFi will typically have a fund administrator, and their job is to handle investments, redemptions. Their job is to independently check and verify the NAV. That's a legal requirement, so that there are no problems with the fund manager misreporting NAV and Ponzi scheme, etc. And also to check that the fund manager isn't misappropriating assets. So for CeFi funds, traditional funds that want to get into DeFi, there's actually no way to easily interpret historical trading data in DeFi. So it's difficult to see them easily getting in. There's also no way for fund administrators to easily perform their governance and oversight obligations, which they're legally bound by. And also, fund administrators have to report to regulators, to investors in specific formats. And those formats are not what we, or how we see things in DeFi. Sorry, that was premature, but anyway. So we talk about composability and interoperability with DeFi all the time. But the question I have is, are we really delivering? And my view is DeFi to DeFi, yes, to an extent. We can deposit ETH into a Curve pool, for example. We can then take the Curve LP token, deposit into Convex, and then enhance our yield, et cetera, et cetera. So yes, DeFi to DeFi, composability, interoperability is great. It's a beautiful thing. It works. But DeFi to the real world, the examples I just shared hopefully give some inclination or some demonstrate how I don't think that we're succeeding at that. So I've talked a little bit about the state of DeFi and how I think we're failing at bringing DeFi to the real world. So my question is, how do we aggregate these brilliant micro solutions into a macro solution that's coherent, manageable, and speaks to real-world applications? I'm going to take a pause here and just tell you a little bit about the work we've done with Enzyme over the last few years to aggregate DeFi with DeFi before I get to DeFi to the rest of the world. So Enzyme is a protocol that enables people to build a tokenized portfolio, manage that portfolio, and it handles all the operational and administrative elements of that. That portfolio can be for a fund, an index, or just for an individual or an organization. Highly customizable. And 4 unique features of Enzyme. The first is that it is a tokenized representation of a portfolio. So when you deposit funds into your portfolio, you receive an ERC20 representation of that, which is redeemable at any time for the underlying assets. The second key feature of Enzyme is that we have spent the last few years building very sophisticated data pipelines underpinning the protocol that enable 24/7 real-time reporting, which is verifiable, auditable, but also historical reporting. And that's on any data metric, not just performance, but also investments, redemptions, management fees, performance fees, whatever. And then another aspect of Enzyme is automation. When you set up a portfolio using the interface, you can configure things like management fees, performance fees. You can set rules around who's allowed to invest, how much are they allowed to invest, is there a minimum requirement, a minimum deposit amount you want to impose, who is the delegated trader, what is, basically anything you want. And all of these things are embedded in smart contracts and automated and enforced at smart contract level. So you get a really high level of automation, which brings down your portfolio management costs and makes you just able to focus on the thing you hopefully like doing, which is the asset management part. And last but not least is the security aspect. Enzyme has a suite of policies which enable you to delegate trading to a third party or people on your team, whilst giving very stringent rules and roles and permissions on what they can and can't do. So whether that's allowed lists of assets, DeFi protocols, or disallowed lists, or cumulative slippage tolerance. So if they consecutively do trades which incur a lot of slippage, you can stop loss them, P&L stop loss, et cetera, et cetera. Sorry, we skipped forward again. Anyway, so that's what we've been doing with Enzyme. And as I said, that's been great for the last few years, but we're realizing now that if we want to graduate from our little bubble in the DeFi space and actually bring DeFi to the masses, we need to do more. And this year, we've been focusing much more on building out a tool suite for composability and interoperability with the rest of the world. That toolkit currently consists of 3 things on our side, Avantgarde Finance, although there are other people and other projects in the ecosystem building other tools, which I'll touch on. The first is the API, Enzyme API, which we just launched. The Enzyme API allows users to extract data from the Enzyme protocol in a really simple way. Another tool we've been working on, or package, let's say, we've been working on is compliance. So compliance tools enable trading with known counterparties or assessing risk of pools before trading to enable more use cases than just DeFi, but also maybe institutional players, regulated banks. And also very recently, we launched the first regulated on-chain platform for fund managers that want to launch completely decentralized funds, but with a regulatory wrapper around them. And last but not least, we launched, we're about to launch, we're still working on it, an SDK. The Enzyme SDK allows users to build transactions and automate sophisticated trading strategies, or just build their own front ends on top, or apps on top of Enzyme. So that's the stuff we've been working on. I will just caveat that with there are other great teams in the ecosystem building great tools too, which I'm going to talk about one of them later. And just to zoom in on the API for a minute, because we just launched this a couple of weeks ago. Basically, the Enzyme API enables you to import your JavaScript or TypeScript project, import data into your JavaScript or TypeScript project. And the client package runs both in the browser and Node.js environment. There's 2 ways to use it if you're technically capable. You can use the pre-built API client. Otherwise, you can send standard HTTP requests to the API. And the API enables you to fetch data on any on-chain trading data, historical or current in DeFi, and it's all standardized. And you can also use that to calculate financial metrics like NAV, performance, Sharpe ratio, etc. And it also enables you to fetch data like assets under management, investments, redemptions, management fees, performance fees, and so on. Pretty much any events on-chain that you can think of. So we've talked about the state of DeFi today, and I've made the case, hopefully, that it's not composable with the rest of the world. I've talked about some of the tools we've been building to help aggregate, compose, and make DeFi more interoperable with the rest of the world. What does aggregation success look like? That's what we're going to focus on next. So I'm going to revisit the examples I gave at the beginning and try to share how we see that. So for a DAO treasury, it's now possible with the API to integrate performance APIs from their treasury management, as long as they're managing an Enzyme vault, into a DAO tooling interface very easily, whether that's Tally, Aragon, or even your own kind of DApp website. It's also possible to integrate a module within Enzyme to price off-chain assets where needed from a trusted source. Sorry. And last but not least, we can integrate, we can use the SDK to improve the user experience and interface on DAO tools to enable roles and permissions to be granted to third-party asset managers, whilst the DAO still keeps full custody of the assets at all time. And using things like stop loss or maximum cumulative slippage policy, you can have guarantees that the fund manager doesn't maliciously or accidentally extract value from the vault. The second example I gave at the beginning was quant funds. So there is a project in our ecosystem, really impressive project called Trading Strategy, which have now built out a completely Web3 native DeFi Python package, which supports automated trading on Enzyme. And they've also, with that, provided sophisticated backtesting capability for more than 2,000 assets. And together with the work they've done and the APIs that we're going to be providing them, they can now integrate reporting metrics and historical data for quant traders in DeFi, whether it's DeFi to DeFi or DeFi to CeFi strategies. So this is another really, I think, cool way that we can expand DeFi into more than kind of TradFi, CeFi funds and strategies. And last but not least, I had mentioned the fund administration example. Recently, when we launched our regulated on-chain funds platform, we actually had to partner with a fund administrator because legal requirement is that, I don't know why it keeps jumping, sorry. Legal requirement is that a fund administrator has to independently check the NAV. So that required us integrating our entire system with their entire system, which took a few months. But now they're able to independently check the NAV by calling the contracts, the enzyme contracts, the tokenized portfolio, and basically verifying it against their own price feed. And they can perform their oversight and governance requirements because they know they're actually in charge of the parameters which the fund manager can, which can be configured at the vault level. And they can also use the API to produce compliant reports as needed. So in summary, I think we need to stop thinking about DeFi as composable and interoperable because we're still very early days in that respect. And I think that real adoption is going to happen when DeFi is integrated in everyday tools and people don't even realize they're using it. So in order for that to happen, aggregating with DeFi isn't enough. And we believe we need tools to help bridge DeFi to the rest of the world. Our approach with that has been building out API, SDK, regulatory wrappers, and much more. And other projects in the ecosystem, like Trading Strategy, have been building out Python packages for quant strategists. So if any of you here are developers and excited by this idea of using these tools, we have recently launched a grants program, and we're definitely interested in hearing your ideas of how these tools can be used to integrate DeFi with the rest of the world. You can scan that QR code if you want to find out more. And also, if you want to learn more about the API, which we launched a couple of weeks ago, there's a blog post we published, and we're always really happy to speak to you about it in more detail. And with that, I'm going to wrap up. If anyone has any questions, I think we still have time. Have 3 or 4 minutes left. Is that right?
We have about 5 minutes for questions.
Okay.
So here's your chance to ask Mona any questions. And I'll call out whoever has a question for you. Right there.
Hey, good presentation, thanks. I'm just curious about like US versus European mindset when you're building for compliance, and are you focusing on a certain area? Where are you from? Where's the company based?
You mean with the compliance tools, or?
Yeah, I mean, I'm most interested in the data, the transparency that you were talking about for reporting, but I'm just asking, like, are you focused on US or Europe? Or are you trying to cater to both?
We're pretty agnostic. I mean, the tools, like, we're just trying to integrate with as many, real-world apps outside of DeFi or within DeFi. But, the focus, I guess, going forward is more outside of DeFi. We've certainly explored US-based partnerships. And I think the way we see it is it's all tooling being provided to a lot of people in the US are already doing DeFi. So if we can provide them tools to just make their lives easier or to make it less cumbersome, and then that drives more people into DeFi because the UX, UI becomes better, then that's something we definitely want to encourage. Oh, sorry, it's not mine.
Any other questions? Right here.
So today, a lot of protocols who need to generate liquidity have maybe committees that are appointed by the DAO or other forms of kind of people making decisions. I think one use case for Enzyme could be running this kind of managed programs for liquidity. So do you envision like the tool being used by maybe committees running this, or maybe even not having those committees from the DAO in the first place, but having more like pushing that on external entities?
The fact that you can impose policies which the DAO can agree on. So things like which assets are you allowed to trade, which protocols are you allowed to interact with. So maybe it's Balancer and Uniswap, for example, and maybe Arrakis if you want to automate liquidity provision. You could also impose like stop losses and things like that. Lends itself really well to being able to then delegate to a third party. It's still trustless, it's still non-custodial, but you're actually getting the efficiency and expertise potentially of somebody external who can manage your assets. And we've seen examples like Avantgarde Finance does some DAO Treasury management for protocols like Nexus, and this has been really useful. They can keep custody at all times, but just delegate management to Avantgarde Treasury for that reason, knowing that there's no way we can run away with the funds or misappropriate the assets because the appropriate policies are in place and smart contract based. I think that's
over there.
Hiya. I know you guys have a regulatory wrapper for Bahamas. Are you guys looking at any other jurisdictions?
Yes, we're working on several jurisdictions in parallel. Some are faster than others, like Switzerland is taking quite a long time, but it's something that we've been exploring for a while. We also are just setting up an office in the UAE currently, so that's where I'm going to be basing myself in 2 weeks after New York with a couple of members of my team, and we've also been working in the BVI. I think I've covered all of them, but yeah, there's definitely an intention to experiment with other jurisdictions and see, ultimately our goal is how can we give the best user experience to people, but still keep it regulated, compliant, because the truth is, with passive asset management, there's a lot of workarounds when it comes to, compliance, but with collective investment schemes, when it's actively managed, it's much more highly regulated, and that's why you don't see many actively managed products on the market at the moment. So that's something we've been trying to crack. We've been working on it for 2 years. Bahamas was the first one we cracked, but we're very confident that we'll crack others in the coming months, let's say.
Perfect, thanks. We have a few more minutes here for questions. There you go.
What's the plan for if a fund manager wants to use a centralized exchange, obviously because everything's on chain, and what's just the general solution for Enzyme for that?
Yeah, interestingly, we've had a lot of people asking questions about that, and it's been a difficult one for us because when you obviously go off-chain with a centralized exchange, you're compromising some of the promises that Enzyme makes on non-custodial transparency, etc. Having said that, we've seen a lot of demand for it, so we are researching a module that will be available on request, hopefully when it's complete, which will enable, because, and one of the reasons for this, by the way, is a very, very popular strategy in DeFi is arbitraging DeFi, CeFi. And so there's no, if you really want to capture the market in DeFi asset management, you have to be able to service both. So it does come with some trade-offs, and it might not be for everyone, and it will be probably an optional module subject to completion of research and development. But it's something that we've actually spent a lot of time quite recently on because we've seen a lot of demand for it.
One more question. Here you go.
Are you expecting, how far do you think the decentralization is going to go when it comes to asset management? Do you expect the demand to be more driven by individuals or by fund managers and institutions?
It's a really good question. At the moment, let's face it, decentralized asset management is a very small market. And we're seeing that, there's maybe 2 or 3 protocols that offer decentralized asset management. Enzyme, I think, is the largest. Index is not far behind, but that's only passive. And D-Hedge, which is active, which is much smaller. But all great protocols and different chains and different features. But we're all actually, if you take the aggregate market of all 3 of us, I think it's like 170 million or something of TVL. Obviously, that's down a lot from the peak, but still, it's very small, a dot in the ocean compared to the asset management market. So I think the demand we're seeing now is, I guess, mostly from DAO treasuries and from small to medium-sized fund managers who have been blocked until now because of the legal questions around it. Going forward, I think, in order to bring more TVL into the decentralized market, you almost have to do it without people really understanding that, like almost like the user experience has to feel almost exactly the same as in TradFi, because it's still a bit too complicated for a lot of people. They have a lot of questions. If you go to an allocator, a fund of funds, for example, there's no way they're going to invest in a fund that doesn't have a DDQ, a subscription doc, terms and conditions, all of this kind of stuff. And so this is something that we've just cracked. And I think it will be interesting to see how that changes now that this kind of option is available. Hope that answers the question.
Great. Thank you so much, Mona, for your time and your informative talk.
Thank you,
Give
guys.
a round of applause to Mona. All right, moving right along here. Next up, we have Raul Calvo from Diva. Raul is a co-founder of Diva, an ETH liquid staking protocol powered by distributed validators that anyone can run with a low number of ETH. Give a round of applause to Raul.
I think nobody drink, so. And what is a remote? Thank you. Okay, thank you very much, everyone, for coming here and joining me to explain you a little bit about the current situation of liquid staking, especially concerning governance, and why we do believe that we need a decentralized governance approach, and we have to incentivize that, speaking a little bit about the whole ecosystem and how we have confronted the challenges that it poses. So I'm just going to speak a little bit, well, first, brief introduction about myself. And obviously, I had to explain you a little bit what are we doing, why I'm here speaking. And moreover, I mean, I think of all the points that I want you to, I want to touch today is why is this important for the whole ecosystem? Who I am? My name is Raul Calvo. Obviously, I'm coming from Spain. If maybe you have felt it by my beautiful accent. Please don't expect me to speak a lot or a ton about technical details, because I'm an attorney at profession. Before joining Web3 or the Web3 environment, I used to be a corporate attorney. I used to set up corporate structures, international structures, and I used to advise, and I still advise in family offices investing in cryptocurrencies. Just to feel a little bit about the mindset about the whole Diva team, or the people that has been behind Diva doing all this time, I end up in Diva and in all this project because I was engaged by some Ethereum OGs, and I was involved already in the ecosystem, participating in other projects. So one of the main things that I want to transmit is that we are working on Diva to be a common good. We never thought about it like a commercial project somehow, on even a commercial opportunity, and we always face it as a common good for everyone. So, what is Diva? Although I already spoke about it a little bit. It's a liquid staking protocol. The main difference, or the main thing that sets us apart to other options around there, is that we are fully integrated, or we are a fully DBT integrated solution. Although there are other projects that are working there, and they are presenting DBT as a separate solution, as a middleware, as all of those SSB, in Diva, we think that it has to be an end-to-end in order for everything to make sense, because if we want kind of to fit in DBT within another liquid staking protocol, what we are going to get is not the optimal solution in terms of tokenomics, in terms of the economic environment, and in terms of efficiency at the end of the day. Because we always think as Diva as a software tool, but the thing is that software tool needs to be as efficient as possible in order to be attractive. one of the main things that I think that also stands us apart is that most of the projects that you can see around there is like a bunch of teams putting together because they want to be competitive and thinking in the sense that, like a company, okay, we are going to launch this, we are going to make this app, or we are going to make this protocol because we think that it's going to be something attractive for the users. In our case, it's a little bit different because it was a bunch of really OGs, people who was in Ethereum at the very beginning, or people who was engaged in staking, that were thinking on how can we improve the current ecosystem. Okay, we were on the verge of migrating from Ethereum 1 to Ethereum 2, or whatever you want to call it, and we were thinking, okay, how can we improve this and make something that works better for everyone? Actually, the idea to end up in a sort of project, or the way that we have ended up, even our fundraise round, it was more kind of an strategic solution to validate our idea in the market than to think of it as from a commercial point of view. This is truly a really open source project in the wide sense of the word. And the second thing that I think set us apart a little bit is that we truly believe that validation, not just staking, but validation, that thing that puts you with a machine and helping make Ethereum, in this case, more secure, needs to be accessible to everyone. This is one of the core ideas behind our project, and we really want that to be one of our core values, if not the core value of the project. And you can say, okay, this is all nice words. We are talking about common goods, open sourcing, something for everyone, but why it is relevant? Okay, the short answer, as everything that has or is related with Ethereum, is because Vitalik says so. That is okay, I don't want to give an explanation. Vitalik has been advocating for making staking accessible to everyone. Validation should be kind of accessible to everyone. He has certain doubts about liquid staking, and he thinks that it needs to be controlled somehow because it can endanger the network. But at the end of the day, he's always advocating for the people to get involved in the ecosystem. So answer, because Vitalik says so. But, step one. But truth to be told, it is not just because Vitalik says so. It is because at the end of the day, what we want, or the people who has been engaged in Ethereum for a certain period of time, we want this network to be successful. And also the networks within the Ethereum ecosystem, such as Gnosis chain or other chains that have been in ecosystem and share the same ethos as Ethereum. We know that being a censorship resistant network is vital. If you are not censorship resistant, you lose all the credibility and you are not useful as a public good. Also, another relevant point is that liquid staking, we always tend to speak about liquid staking as DeFi or some kind of a new DeFi level. And no, we are talking about core infrastructure within the Ethereum ecosystem. We are not doing, I don't know, leverage staking or any other thing. Sorry. We are not doing leverage staking or any other thing that may lead us to think that this is just an economic tool. We are doing core infrastructure. This is a software that is going to help Ethereum to become more resilient and more, actually more useful for everyone. And the last thing is that liquid staking, or in any sense, staking pools is known to be considered one of the best or the most used cases within this new staking economy, or this new staking Ethereum. Whoop, this is moving a lot. Okay. What the networks that the risks that the network may face? Obviously, the regulatory risk. I think we all have seen the risk that we are facing with Tonala Cash, now open like 4 days ago. regulatory crackdown on teams that are building open source software is true. It's a reality. It's not something that we are creating, and it's very real. So if a regulator thinks that Ethereum needs to be controlled, I think we can give it for granted that they will do anything at disposal to try to control Ethereum. So we have to do something about it. Obviously, the other two major risks I think are well known by everyone is someone who is willing to attack the network because wants to make some profit. Maybe validation is not the best way to approach or to make a profit out of it, but it's something on the table. If you can reorganize or you can set up your daily transactions, obviously there are a ton of money to set out of there. And there are always other attacks, like just people that want to prove that they can break the things for other things. That's, I don't know, maybe a bunch of Solana maxis, they want to attack Ethereum and to prove that Ethereum is not that resilient, and they decide to do something to harm the network. It is important, and again, I'm coming back to our ethos as a project, that we have, and I truly believe that we have to interiorize that we are not just working in other area within, I don't know, software development, the ecosystem, or in a global environment, I don't know, whatever. And this is something that I honestly think, we really have a chance to make a difference and to set up the infrastructure that anybody can use. And that should be something that is taken as a duty for everyone that is working in this ecosystem, like, okay, we are not here just to make money, or just because we are thinking that it's a nice way to, I don't know, improve our lives of our careers. We really have a once-in-a-lifetime chance to set up a difference for everyone. And maybe you think that this is absurd, okay, I'm doing a really small protocol within the whole Ethereum ecosystem, but any little piece, any little bit that we can give to the community and to help to make this a solid ground for everybody to use and help to build public goods should be done. And not because we just want to extract some profit out of it, it's because we have to. We are committed by the trust that the people is putting on us to build something better. When we started Diva, we obviously, as everybody else, I was saying, we were coming from the ecosystem already, so we're looking around what was out there. And what we found, and I think this is obviously well known by everyone, is that the liquidity staking market was already almost monopolized by one actor. Actually, when we started thinking about Diva, there were two main actors. Lido and centralized exchanges participating in somehow liquidity staking. And in terms of governance, what we have seen is we analyze the competition out there, or we analyze all the other protocols, and we have seen is two different approaches. Off-chain governance, which tends to be easy for everyone kind of to participate on it, but at the end of the day, generally it depends on multi-sigs, a team that is controlling behind, and there are certain centralization risk, or at least is what we detected, and on-chain governance, which tends to be a little bit more decentralized in a sense, because you are not relying that much in multi-sigs or something that is being executed. But the thing is, what we have seen is that the things that were before us, they took certain architecture decisions when implementing that on-chain governance to solve the problems that were there at that time, and maybe not thinking that much about that centralization risk. They were more thinking on safety of the users at the end, on the resiliency of the protocol, but that leaves us an on-chain governance with a myriad of committees, multi-sigs, oracles, and cross-dependencies that at the end of the day prejudice the whole governance system. In terms of market diversity, something that has been pretty popular last days has been self-limiting. The self-limitation, and actually has been debated in our own community, in the Diva community, is kind of the main approach. There has been a strong debate lately about shall we set limit, do we have to take this path or not? And I always say, to me, it's extremely easy to say yes. I mean, why not? Let's self-limit. But truth to be told is either myself or anyone within my situation which is advocating for self-limitation, we are not holding that position in the market. Actually, once Lido has said that they are not self-limiting themselves, okay, we are going to commit to self-limit, but it is like the picture I'm showing here. Okay, we are a couple of kids trying to aim for giants and try to self-limit something that maybe I'm going to achieve in years. So yeah, self-limitation, but if the leader of the market is not self-limiting itself, I mean, there's nothing we can do on that front. There we go. Why? And again, I don't think this is a good or bad position. I totally understand the Lido's point of view or Lido community point of view. The reasoning is that this is a market that winner take most. So they are saying, okay, most probably there is going to be one major actor within the ecosystem who is kind of control everything. And if somebody has to be that actor, why not myself? That at the end of the day, we are well-intended, we are mostly decentralized in the governance and at different layers. So it's kind of, I'm safeguarding the whole Ethereum ecosystem against other agents which maybe do not share the Ethereum ethos as ourselves, like, I don't know, Coinbase or centralized exchanges. So my personal take is, yeah, I mean, I kind of agree with their point of view from a free of market or from a liberal point of view. I don't think the economies need to be intervened or the players in the market need to be intervened somehow. And I mean, at the end of the day, I don't think that is a net positive result for a market. But truth to be told, I don't like a monopolistic market either. If we are Ethereum, or if Ethereum becomes a market with just one single actor in one single sector of one core infrastructure for the whole Ethereum ecosystem, we are fully dependent on that single actor. So, okay, from maybe an ideological point of view, I can agree with that, but when it comes to reality of the market, I will say, okay, maybe something should be done in order kind of to limit that perspective. And last, I honestly, and this is myself as a lawyer talking here, I don't really buy the idea of, okay, one centralized actor is going to jeopardize the whole environment, because all the centralized actors are not really wanted to get into the regulatory exposure that is going to give us if they kind of control Ethereum somehow. I'm going to speed up a little bit because so we tackle from the point of view of decentralized governance. So we are not kind of self-limit the market. We cannot enforce to other players in the market to self-limit themselves. We just kind of put our best in self-limit ourselves and hope for the best to for the rest to do the same as us. So the thing that we can tackle and that we can push others to tackle is to adopt a more decentralized approach in governance. And in our case, what we did is we set up a plan based on 3 different points to tackle the decentralization, taking into account that at the end of the day, if we are launching a new protocol as ourselves, you don't have to believe that that community, that fully decentralized community, is going to be around and to be created from one day to the other. They tend to follow people. Nobody wants to take the lead. So we had to find kind of a middle ground to kind of push the people to get together and to form that community that was going to take ultimately care of maintaining the Diva protocol. Our plan, or the 3 steps of our plan, was based in these 3 pillars, which is let's create that community from the ground up by selecting the people that has been involved in other communities, so they are mature enough kind of to take the lead within the community without needing us. And in terms of architecture, we have seen that other people were taking decisions based on other thinking, not just in setting up the decentralization from the very beginning. Maybe it's because in our case, as I'm a lawyer and I've been insisting and pushing the team too much to kind of distribute at least the risk on setting up something out in the wild, we are taking certain architectural decisions from a different point of view. And first, but no less important, are the core contributors that were at the very beginning with the Diva protocol. We truly believe that we have kind of to step down a little bit and to take the community, take the lead. It's not that they don't want the people to follow us. We really want the people kind of to take the lead and help to take care of the protocol and the software that we are open sourcing and that we are giving to the public good. And the way that we are doing, I spoke a little bit about this before, is we have chosen the best people that we can find out there. And in terms of technical solutions, so something that we have given to the market, we just changed a couple of lines of codes within kind of the standard governance contract, and we created a de facto two-token model. Any software developer here is going to say, OK, you are not creating a two-token model because it's going to be just one token with a different property. I buy that, but from a legal point of view, the moment that a governor doesn't recognize a token that has not been delegated, like in our case, we are creating a de facto two-token model, because only the tokens that are delegated count in terms of participating in governance. It seems to be working so far. I'm going to speed up because I just have 10 seconds, but it seems to be working so far. I think we are on our way to achieve our goals to create a solid community, a solid decentralized community. In terms of the different points, as you have seen, I'm coming with a t-shirt of Diva, a t-shirt of Samuel Labs. I don't have a bracelet of the Staking Foundation yet, but as you'll have it, we are really decentralizing from the very beginning before releasing the protocol to mainnet. And let's try to finish here. We want to improve a ton of things. We are relying too heavily in delegation because it's the only way kind of to get a community together at the very beginning, at the early stage. But we want kind of to make it more decentralized, not rely that much on delegators. We are working extremely hard in creating a diversified geographical distribution of our validators, of all the validators. This Staking Foundation is running, or is working actually in running programs to push the decentralization from a geographical point of view. And our core value is we want the average user, anyone without almost any technical knowledge, to be able to become an Ethereum validator. I just ran out of time, so jumping on the recap, and thank you everyone for hearing me ramble a little bit.
Thank you, Raul. Thank you, Raul. We have a few minutes for questions.
Yeah.
Over here. Yes. Mona?
Can you talk about the governance and curation process you touched on a bit, and what the strengths are? Because obviously governance is quite a difficult thing to get right these days. Would love to hear a little bit about the design.
Yes, I mean, actually, the design, well, first of all, thank you very much for your question. In terms of design, it's nothing that innovative. I mean, the biggest difference that we have introduced is that we have kind of separated, instead of taking into account all the tokens in terms of governance, so generally is what happens on all the projects. Generally, the founders, early investors, they have a kind of a leverage power over the governance, so they can take over the governance at a certain point of time. We have divided straight away between delegated and non-delegated tokens. In terms of governance, just delegated tokens are taken into account. In order to delegate, you have to carry out an on-chain transaction, pretty simple. So I was mentioning it's just changing a couple of lines of code. What is the thing? That as long as we are yeah, the co-founders, the early investors, we are not delegating our tokens, which is something that anybody can see on-chain. We are kind of limiting our influence over the whole ecosystem. We are refraining to take any participation on delegating the token so far. And so actually, and I think is this graph, one of the good things that we have got, doing this is that all that people that is there is people who were somehow airdropped with the token. So it's people from other communities. And as you can see, it's pretty distributed. One of the things that we want to improve, and I was saying, is a delegation model, although we are taking that delegation model because at the very beginning, especially, the people is not that active, and they rather prefer to delegate it to someone. It's something that we want kind of to push a little bit towards a more decentralized approach at a later stage.
Thank you so much, Raul. That's time for us, and we'll keep it moving here in about 1 minute. Thank you, Raul. Give him a round of applause. Thank you. All righty, we'll get started here with our next talk. We have Cassidy Daly from Centrifuge. Cassidy is a co-founder at Centrifuge, bringing real-world assets on-chain. Her talk is entitled "Developing Standards for DAO Treasury Management." Give a hand to Cassidy.
Hi, everyone. I'm Cassidy from Centrifuge, as mentioned. We actually started off working in Berlin at Full Node, the Gnosis co-working space. So it's nice to give this talk here in Berlin, although we're actually based all around the world now. Centrifuge is real-world asset financing on-chain. And today I want to talk about DAO treasury management, which I think has always been a really important topic, but it's newly relevant. And today I'm going to go into exactly why that is. So first off, what is DAO treasury management? It's really, I think, based on the fact that most of our DAOs have native tokens, and they mint those native tokens oftentimes to actually fund development of what the purpose of the DAO is. So DAO treasury is usually made up of those native tokens, and oftentimes they do a token sale and actually get other types of assets. So DAO treasuries are made up of their native token, probably making up a big chunk of it still these days, but also stablecoins, ETH, Bitcoin even times. And so the DAO treasury management itself is really all of the activities that are involved in custody of those assets, the strategy of how to manage those assets, and then the actual trading or management of the funds themselves that are held by the DAO. And I think what's unique about DAO treasury management as compared to traditional corporations is that there's a little bit of a different mandate when it comes to a DAO. So just like other corporations that have a treasury, you're obviously managing your liquidity and you're managing your risk. So that means that you're really planning for the current needs of the DAO, what your short-term spending is going to be in the next year or so, but you're interested in also having capital preservation strategies to make sure that the DAO can really fund itself into the long term and fulfill its mission. Because most of our DAOs do have long-term missions, right? But I think what's unique really about DAOs in particular compared to traditional corporations is that they really do have a core mission that tends to be crypto native in nature. And really the management of the treasury should be aligned with what the DAO itself is trying to accomplish. And oftentimes that means supporting its own ecosystem. So in the example of, let's say, Ethereum, the Ethereum Foundation would probably want to put a lot of its ETH into supporting projects within its ecosystem, right? So I think when it comes to the management of a DAO treasury, we do see a little bit of a different approach. And that's why I think approaching this as a manager for a DAO treasury is a really unique problem that a traditional manager for a corporation's treasury wouldn't necessarily fully understand the needs of the DAO and be able to employ a strategy that meets both of these things. So when a DAO is actually deciding its goals, deciding how to deploy a strategy, I think there's really 3 buckets that we can look at when we're looking at portfolio allocation. So that's, again, this liquidity portion of what are the short-term needs of the DAO, how much money are they going to have to spend on developing the protocol this year, right? How can they pay out the grants that they've given to teams, different development teams, auditing teams, whatever have you for the DAO? You need to understand what that looks like in the short term and be able to have a liquidity strategy to actually meet that. But then on the other hand, you probably will also want to have preservation and appreciation strategies to be able to actually have the DAO treasury either grow or not be depleted too much to be able to fulfill its long-term visions. So I think these 3 buckets are really what we're looking at in terms of how managers today for a DAO are looking at deploying their capital. And oftentimes, or at least up until this point, that's really been only crypto-native strategies that they've looked at. And so right now, when we're looking at DAO treasury management, it tends to be pretty simple, and it's usually just holding a stablecoin as part of having that liquidity, and actually deploying pretty leveraged, sometimes risky crypto-native strategies. And I think what we're looking at Centrifuge, and what I'd like to dive into a little bit more today, is being able to take a step back from only looking at the crypto-native side. And I think the reason for that is really because of what's happened in the market, right? So we had this amazing bull market where we saw DeFi TVL shot up, and that is where these crypto-native strategies were really useful. And I think made these DAO treasuries grow quite a bit. And I think it was actually really great time for a lot of these teams to start deploying a lot of these, or really synthesizing the governance process around how we decide what a DAO is going to do with its treasury. And so I think this bull market was extremely meaningful in really building that infrastructure, giving teams a reason to work on the legal infrastructure, the active managers to come into the space, because there was a real opportunity to provide value here to these DAOs, and also developing the governance process to go along with both of those things. But unfortunately now, in the bear market, I think it's really an important time to start zooming out of just these crypto-native strategies. And the reason is that DeFi yields are just lower than TradFi yields right now. So I think this is the reason why we've actually seen quite an explosion in interest for US Treasuries. I think this is something that's more interesting than a lot of DeFi yields right now. But I do think there's much more beyond just relying on something like US Treasuries to diversify a DAO treasury into as well. But this is just an example of what we're seeing happen in the market today. So I just wanted to, bring up this point of, well, if all of these DAOs understand this, it's a well-understood problem. Why don't I see a lot of activity happening in DAO treasury management right now where they're actually starting to diversify out of crypto? And I do think a huge reason for that is the fact that we just did not have the tools yet. Why now? We actually have a stack available for these DAOs to do what they need to do to actually actively manage that treasury. What does this stack look like? I mean, it's teams like Safe that actually have real custody solutions that I would say are finally getting into a place that's institutional grade. I mean, a place where an institution that has a legal mandate to have proper management of its funds can actually start using Safe to custody those assets. We have governance. I think Gnosis actually is doing a lot of really interesting work here that I'll dive into in a few minutes, of actually developing a sort of standard, we could call it maybe, of how to actually have governance around how to deploy your treasury. We've got stable coins like Maker's DAI. Aave's just launched Aave Go. We've got managers like Karpatki that are going to be talking on the panel right after me, reporting like Steakhouse Financial, and then Centrifuge, we're really focused on real-world assets. And another thing that we've really tried developing together with Maker is also this legal aspect. So I think 3 really key elements within this stack that I'd like to touch on a little bit deeper are the portfolio allocation that we focus on with Centrifuge, the legal infrastructure that a lot of teams are really focused on developing, and this DAO governance aspect. So for this portfolio allocation piece, we've launched Centrifuge Prime. We've really built this specifically for DeFi native organizations. And one of the things that really outlines this is this work that we've done on a DAO legal wrapper. I think what's really important to point out here is that creating something, some sort of legal structure for a DAO should never be a legal structure that encompasses the entire DAO. It's really a specific entity for one piece, one purpose that's specific within the DAO. And the important thing there is that you don't want to have the liability of whatever this legal entity is doing carry over to any other DAO participants, and also vice versa. You don't want anything else that the DAO is doing to then allow any regulator to target this legal entity just for something that someone else in the DAO is doing. So it's really important here to have a legal structure that's really narrow in its purpose and specifically focused on, in this case, allocating a portfolio of the DAO's assets. And so that's something that I think is still in development, probably working together with regulators to improve and improve. But I think we've got something here that, Maker's happy to use, at least for now. And I think and more DAOs are going to start to employ this to basically enable their on-chain treasuries to be able to invest in assets off-chain, and even invest actually in other on-chain assets in a more legally compliant way. So that legal infrastructure, I think, is really key. But the other aspect of Centrifuge Prime is really our bread and butter, which is this ability to really diversify the portfolio of a DAO into different types of real-world assets. So again, looking at those other buckets that we looked at earlier, liquidity, preservation, acceleration, being able to have a portfolio allocation strategy that invests in all types of different real-world assets. Another thing that we've brought into our ecosystem is what we call the credit group. And these are a group of credit and finance experts that really will help to inform DAO treasury managers and work with them on hopefully creating a strategy that really works for this DAO and being able to understand how these assets fit into that strategy. So when we think about portfolio allocation, a lot of that should really happen within the DAO and in that governance process, and that's that process that I think we're still seeing develop. But the DAO should allocate to the different buckets of these real-world assets. So for example, maybe they would decide to have a specific allocation of the DAO, maybe let's say 10% of the DAO's assets they want to deploy to different types of real-world assets. Of that bucket, maybe they want to put 70% into US Treasuries and 30% into other types of credit. And so the DAO will have a vote to actually decide on that allocation. This allocation can then be worked on together with the treasury manager of the DAO, together with the Centrifuge credit group as an example, to really decide exactly what kind of strategy to employ. But it really then comes down to DAO governance to actually approve what those strategies are in a vote. And then, using Centrifuge Prime, be able to automatically allocate that portfolio the way the DAO has actually governed on-chain. So I think what we're trying to do here is take what we see in TradFi, but really bring that on-chain, I mean truly on-chain, where you have the DAO really governing down to the T exactly how you're deploying these assets, and be able to have this automated in a way that is ideally trustless to the extent that you know as a token holder that your decisions are actually being employed without you needing to double check on them. It's all happening trustlessly on-chain. I think the governance aspect here is a really interesting one that we're still developing. And I wanted to highlight a couple examples of how that's going. So one of those is a Steakhouse Financial, this reporting proposal that they made to ENS. And I think ENS has actually done a lot of really interesting work in creating a governance process to really facilitate how they're managing their treasury. So that was a really good example that I think if you want to take a look, something really interesting to get into. And another team, obviously here at DAppCon, Gnosis, is really, I think, leading the way in terms of having a robust governance process around how they govern their DAO treasury. And so this is a proposal here from Karpatki, one of those active managers, that's working with the Gnosis DAO to create, together with the DAO, together with the token holders, a strategy that works for those token holders, that is aligned both to the mission of Gnosis, but also able to employ strategies that would preserve their capital in the long term, preserve their liquidity for the short term. So I think this is actually, for me, one of the key examples of creating a standard, hopefully, for other DAOs to follow in step of what Gnosis is doing, learn from them, and understand that this is all something that can actually happen on chain. I think one thing that's really interesting about Karpatki and the way they work with Gnosis is that they use another Gnosis team called Zodiac to actually on chain have a clear mandate that the DAO is actually able to set. And it's completely enforced on chain, where Karpatki is not able to actually employ strategies that have not been decided by the DAO through this governance process. So I think this whole progress that we're seeing with all three of these things, this legal infrastructure that we're developing, the portfolio allocation that you can now do with Centrifuge, and this DAO governance that teams like Gnosis are really leading the way in, I think these are really key areas that we're seeing of development where we are in a new time, where this has always been an issue for DAOs. This is always something that DAOs have wanted to do something about. Newly in the bear market, really looking at assets that are outside of the crypto native place, but really because we have the tools. Both of those things are, I think, really key reasons why right now we're seeing a lot of growth in this area. We're seeing a lot of DAOs actually really start to go into this direction of deciding how to allocate portions of their treasury to real-world assets. And I think, for me, that's really exciting, obviously, working at Centrifuge. But I do think one of the key things here is that we make sure we're continuing to do this on-chain. We're not just replicating what traditional finance is doing. We're not just replicating the way that corporations today manage their treasuries. We're actually building new tools and new infrastructure to be able to do this in a transparent and in a trustless way so that DAOs can meet their needs to be responsible stewards of capital for the DAO, but do it in a way that's actually happening as trustless as it can be on-chain with these new pieces of infrastructure. So that's all I've got for today, but I do have a few minutes for questions.
Thank you, Cassidy. We have a few minutes for questions. Over here. We have a microphone, so just give us 1 second.
Hi there. Yeah, I think you mentioned at the start of your talk that a lot of the treasuries have it's stored in their native token. So I wanted to know if you could go a little into depth on how you convert the native token to something else, which is more liquid, and then you finally take it onto real world without like having a price impact on the token in some way.
Yeah, I think that's a great question. I think a lot of teams are always thinking about that. There's a few different ways that a DAO could go about this, depending on how much liquidity there is for their native token. So, there's one bucket of DAOs that might have a high volume of trading for their token. They could actually probably use like an OTC desk in this case to work with another team that would be able to very slowly trade that token for a stablecoin, for example. So, but that's really only limited to very large DAOs that have highly liquid tokens and large token volumes on the market. In the case of most DAOs, I'd say they probably fall into a different type of bucket, which is really that they end up doing things like private sales to key investors, or doing a public sale where the native token is then locked over 2 years, for example. So you see both of these different examples now, and these are in existing teams. Obviously, a new team generally ends up starting off with some sort of a private sale or public sale as well. But I think the key there, like to your question of not moving the the token price too much, I think, is having either really high token volumes so that the price isn't moving very much, or locked tokens when you are selling them.
Have another question for Cassidy? If not, we'll wrap it up there. Thank you so much, Cassidy, for your time. And next up, we have a panel discussion. We'll take a short break, and we'll switch out the stage and then kick it off to round out this section of talks for today. Thank you so much, Cassidy.
Thanks, everyone.
No, I'm fine. For a few steps I can do. Okay.
Like this?
Okay, yeah,
Okay.
I'm fine. All right. All right, cool. Let's get this panel started. Yeah, we will talk about DAO treasury management and on-chain treasury management. And kind of instead of doing an introduction, I would ask each of one of you to kind of describe how they got involved. I'll probably start with Mona because I believe you were kind of the earliest. So I remember back at least, well, you even said 2016 you started. So maybe you can just give us a short overview of your journey from there to here.
Yeah, so at the end of 2015, I had just closed a hedge fund, which I tried to start, which was a complete failure. And one of the biggest challenges I faced was the operational and administrative headaches for small to medium-sized managers. So I actually closed it down and was going to take a year off and just try to recover. But about 1 month in, I discovered blockchain and became completely obsessed with the space. Saw that if the future of assets is digital, then we can automate the entire operational administrative side of asset management. We can aggregate processes, and we can disrupt a lot of intermediaries. So in, I think it was officially June or July 2016, I founded Melonport, and we did a token generation event, one of the first, I think. And we then later rebranded to Enzyme, and still standing.
Great, great. Cool. Masi, what was your first touch point into the topic of, well, DAO treasury management?
Yes, Karpathy started with Gnosis. So Karpathy is a spin-off of Gnosis. We started with the management of the Gnosis treasury. So back in that moment, it was around 2020. We were experimenting with a lot of safe tooling. And then we started evolving, working with other DAOs. And in that moment, we started realizing that there are a lot of financial functions that are not being covered by most of these dev teams. So we started covering a lot of functions from the traditional CFO functions. And then we started working with other DAOs, and we found that there are a lot of positive sum games that anything related to, let's say, investment, traditional investment banking. So you can think of debt market, risk management, capital preservation. So this is how we evolve into building financial products and services, in addition to our main goal, which is to preserve the DAO funds for the mission of the DAO.
Cool. Marc, you, well, are a well-known participant in the Aave DAO and community, so maybe you can tell us what was maybe a first moment when inside of Aave people realized, well, we kind of have a treasury and we might need to make decisions about it.
It's actually a good journey of decentralization when you think about it, because even my role, I started like one of the earliest member of the Aave companies, which are the creator of the Aave protocol, and then deploy it, and then with decentralization become more and more involved with a decentralized autonomous organization. And with Aave V1, there were 0 treasury management, because DeFi was nothing. In January 2020, DeFi was nothing. And even the way the protocol generated fee was like a very different model than what we have now. But starting from 2021, with Aave V2, fees started to be accumulated continuously by the protocol with the A-token system. I will not go into the technical details because we have better things to do. But we took the design decision as a DAO, and it was a DAO decision, not a company decision. It was the process of decentralization already in 2021 to basically collect the fee in A-tokens. So basically the DAO itself became an Aave user and an Aave liquidity provider. Yeah, and basically it makes sense. A DAO should believe in its own product, and a DAO should make the money work with the treasury from the yield as any other user, because that's the point of DeFi and decentralization. The DAO should be a user like everybody else, and the rules of the game are the same for everyone. And and I will finish on this because it's a long answer. Now we are in 2023, and we are on Aave v3, and the protocol is profitable. So the DAO has service provider, and the DAO spends money, and the DAO has revenue, like reserve factor collected on interest, and there's a surplus. So what do we do with the surplus? And because we are a DAO, I don't have an answer, and the company doesn't have an answer because it doesn't work like that when it's decentralized. The answer? Karpatki or other service provider go to the Aave governance and say, hey, let's do something with that money. And then as a DAO, we vote and we decide what to do with it. And I think it's how it should work. It's a progressive decentralization journey.
I'll take a comment you just made here when we were in the room, and you said kind of, well, right now as a DAO you can easily, or well, you have access to things like, let's say, this maker stability fee rate, where you get 5%. So maybe that kind of opens a question to you. Where would you see is the need, or I guess you are making the point, DAOs should still go beyond that. Or maybe what's the answer to that?
I think me personally, I don't think a DAO's job is to 2x, 3x, 5x their treasury at all.
For sure.
It's actually the opposite. I think that's extremely irresponsible. I think the DAO should be looking to preserve runway, to achieve certain strategic goals, and put capital to work. Now, there is a room for risk in every portfolio. It just needs to be sized appropriately. So it's all about sizing and taking the holistic approach. But I think, the majority of a DAO's assets should be in something, risk-free rate at least. And if you can outperform the risk-free rate slightly by having a small portion of your assets in something a bit riskier, that's fine. But you have to take the holistic approach to portfolio allocation.
And I would actually go a step further or answer similar different and say, kind of, even that, where you say it should be simple, you could kind of just take the DAI savings rate, 5%. But even that is kind of, if you actually have to do it, it's not that simple, because you still have to define rules of, well, kind of who's allowed to execute that, when would you switch to something that, like if Aave offers 6%, then should you switch? How often should you? Or maybe you can expand on that, kind of the complexity of even kind of just earning the risk-free rate.
Yes, but the thing is, we need to make sure we have the DAO's goals in mind. And we're not trying to build any type of hedge funds. We're not trying to compete for yield. So I'm very much in line with what Mona mentioned. Key thing here is runway. Then there is some extra risk appetite, and then we can think of some volatile assets and some other yield opportunities. But the main thing is, the treasury. It's to fulfill the mission of the DAO. That's either grants, development, and definitely not to compete for yield.
And I think it's important for each and every DAOs or project, depending on where they are in the spectrum of their decentralization journey, to define where are their risk appetite. I have a few examples, should you go for more and more yield? Two stories I want to share, because I love those protocol names, it's good experience and bad experience, like the Angle protocol that do the AG-Euro stablecoin. Historically, they deposit their treasury into and did direct deposit into Aave. And at some point, they implement a new treasury management system that was looking at the best yield on chain, and they decide to move the treasury from Aave to Zeller. Unfortunately, 2 weeks ago, Zeller got hacked, and they basically lost all the money on this. Obviously, they find the money back, and the Zeller story ended well, but the difference, the premium on yield was 1%. So they basically risked dozens of millions of dollars for 1% more yield. Is that something you want to do? On the other opposite side, when you can make 3.5 or 5% on Aave, on MakerDAO DSR, is it worth the risk for your treasury if you are a young project that just raised money from investor and still have to deliver your MVP and find product market fit? Maybe it's okay to earn 0 and get eaten by inflation, because you cannot take the risk to fail. You cannot take the risk to Aave getting hacked or something bad happen in Maker. And I think it's fine too, because so many young projects in the ecosystem got completely wrecked by Encore. during the Terra Luna story, because they were raising money and depositing that into Terra Luna to make 20%, because it was sound investment to make 20% on their stablecoin. And then when Terra Luna happened, the project was dead, and so many had this risk. So it's important for every single project to define what is their risk appetite, where they are in their decentralization journey, and who takes the decision. Is this a company taking the decision? Is it the DAO taking the decision? And what do they want? Do they want stability? Do they want to preserve purchasing power of the DAO? Or do they want to expand the capital and the treasury of the DAO?
And maybe just as a step before that, even, I think, because a lot of DAOs don't do this, is just like financial reporting. Like, if you don't have financial reporting, if you don't know what you're spending on, what you're forecast to be spending, it just doesn't, I mean, you can't actually even think about managing a treasury if you don't know what you're dealing with. So having your financial reports in order is key.
Right on.
Maybe let's talk about that one, because I would say, first of all, that is one of the kind of big things that, or big benefits that, in principle, all funds are on-chain, and you might think, well, therefore it's obvious kind of what a DAO has, and kind of you can immediately see it, but maybe the reality is more complex than that, and you can talk about that.
I think anyone who's tried to analyze what a DAO is spending, you know, is it just a foundation? Is there a foundation? What are the multi-sigs? The data is just not there. And even if it is there, sure, you can see what's going in, what's going out, but you don't have any idea what those payments are. It could be a loan, it could be, which is coming back, it could be a salary, it could be a one-off strategic payment. So if you don't have proper reporting to state what it is you're spending, the numbers are meaningless. Sure, you can see the absolute numbers going in and out, but there's no story there.
Just the bare minimum, having a budget, like right now, and that's something we are working on, because the DAO is like one of the largest DAO in the ecosystem and one of the largest DeFi protocol. The DAO doesn't have a budget. I cannot tell you what the DAO is like prevising to spend in 2023-2024 exercise. No idea. We have good reporting, like because Llama started the work, and Token Logic, which is like a new service provider to the DAO, did some kind of reporting to how much the DAO is actually making, how much the DAO is actually spending with service providers. So when I say the DAO is profitable, it's backed by actual figure, but there's no actual budget. Like, we are so immature as an ecosystem. Obviously, it's step by step. Like, the whole ecosystem is 2 years old or 3 years old, but we have definitely a margin for progression.
And maybe both of you can also kind of share a bit about, well, obviously you're building those, or kind of trying to solve that with, reporting tools.
Yes, of course. There is still one missing part. For most of these DAOs, there is an important part of the ecosystem, which is centralized exchanges. That's still the part we lack a little bit of accountability, transparency. And yeah, I suspect, hopefully, most of trading volume is going to migrate to DEXs, but that's a challenge we have, right? It's these black boxes, especially we have this thing with market makers. Many of them, struggle with reporting what they're doing with these funds. So this is one of our goals. We need to avoid as an industry, how to avoid these FTX things again.
But where do you put the limit? Because I think transparency and auditability is great, but do you care that how much someone at Gauntlet doing risk report for the DAO is making? Like, I don't care about the salary. I care about the budget. Is the budget too high, too small? What do we get back as a service from that budget? But I don't care if they spend like $200 to buy a coffee machine in their office. Like,
of course.
I think it's more important about categorizing the payments. So, if you say, okay, for years 0 to 5, the protocol was at 95% expenditure was software development and 5% was, biz dev. And after 5 years, you say the protocol is more mature. So should that ratio still exist, or should we be more like 50%? And now it's time to accelerate biz dev on the protocol. And so it's more about allocation of resources and total resources, and thinking about, strategically thinking, where are we now in our roadmap? Where are we now in our cycle, and what do we need to throw money at? In terms of going back to Martin's question on transparency and reporting, I do think it's important to, especially in this kind of decentralized world that Web3 world that we're building, I do think when you have stakeholders, they should be privy to that data. I think it's a good thing to have 24/7 transparency and historical transparency. It doesn't have to be at a line-by-line level, but it's something that we've invested a lot in with the Enzyme protocol as one of the development teams behind it, which is building data pipelines, on-chain data pipelines, underpinning the protocol, which give you historical reporting on any metric, whether it's trading, NAV, inflows, outflows, whatever, and also and also 24/7 real-time reporting. And I think that's a powerful tool that you can easily integrate with APIs into other DAO tooling apps or even your own DAO interface.
Yes, also another thing that is super important is this accounting stuff needs to be open source, so anybody can audit how we create these reports. So this is the essence of everything we do.
Talking about accounting, how far or how large would you say is the gap between kind of what we do as accounting to at least have a sensible kind of dashboard or that helps us really understand what's going on, compared to what in the traditional world you would need to file, I don't know, kind of file a balance or file that?
I think there's two parts. I think there's asset management, and in asset management, I think we're there with reporting. I mean, obviously there's some improvements to do, but like I said, if you use a tool like Enzyme that aggregates the reporting is there. The financial reports and accounting is much more hard to automate. I've seen teams like Carpet Key produce reports for DAO treasuries that they manage, which are great. But I'll leave it to Marcelo to comment on how easy or not that is to automate. I think you can automate some parts of it, but it always requires a certain expertise and diligence, I think, to check the data going in and verify it and produce it in a certain way.
For complex organizations, I suspect accounting will never be able to fully be automated. And we see that's a global problem. Largest companies still cannot do it. But still for DeFi protocols, that's something that definitely we have the magic there to have everything 24/7 auditable.
Maybe something you can see though, and something we are seeing is tools, accounting tools, very similar to what you use in traditional accounting, like Cryptio, for example, which help you filter in data from wallets, and then if somebody on the team is labeling that data correctly, that helps reduce the workload a lot. But it's, like Marcelo said, I think it's very difficult to fully automate end-to-end.
Yeah, previously you have been, of course, mentioning the big risks or kind of, still smart contract risks. What would you say is the state of getting insurance for those?
It's actually like the big elephant in the room for all this kind of stuff is that DAO are not legal entity. And that is a blocker for a lot of things, and it's a source of frustration and interrogation for a lot of details and friction. So for example, I'm a service provider. I have like a regular old company, like the Aavechan initiative is an actual company that invoices the DAO for services that is paid directly from the smart contract of the DAO. And some regulator will tell you, well, a DAO doesn't exist, so a DAO is a group of people, and because a DAO is not a company, well, you have to pay VAT, because it makes sense. You cannot get back VAT on something that is not a company, and that is not incorporated in any country. Other regulators will tell you other things and things like that, and the thing is that nobody has like strong answer. And if we want to have insurance that are actually regulated product, if we want to have actual accounting, if we want to scale and professionalize, gain maturity in the ecosystem, at some point we will need to define what a DAO is. Because you asked 20 people in this room, you would get 20 answers. And none of these answers would probably match what the regulator will say. So at some point we need to understand what we are talking about in terms of regulation, to make those things happen and scale.
Yeah, kind of rephrasing that question to both of you. So I would say currently I mean, maybe there are like 20 to 50 DAOs that have a treasury that might be worth managing. So what do you expect your kind of future market is? Will there just be much more DAOs, or will there be kind of just regular companies, entities that well, start to have funds managed on-chain?
Well, we're seeing a lot of DAOs, especially DeFi protocols, migrating into each other specialization. So this is something we're seeing today. I suspect in the future, and coming back to your previous question about insurance, I suspect this is going to be a huge industry, emerging industry. And for the next iteration of DeFi, it's going to be critical insurance. In the last bull market, the solutions were quite mature, mostly because the market wasn't mature. We didn't have enough liquidity, and the price for insurance was too high to be able to insure all of these DAOs. But there are a few teams that are emerging, mostly data analytic teams, doing reports, doing alerts. Like, for example, we're working with Hypernative, RiskDAO, Redefine, and a few others. And this is I suspect all of these teams are going to be somehow the future for the next iteration of DeFi, hopefully a more resilient one and the safest one. Yeah. So this is where I see something more a professional, let's say, and something that can eventually cover most of some systemic risks, which are impossible to tackle in TradFi. I suspect this is one of the directions we're taking.
But I'm sorry to play on the semantics here. All these things are not insurance, because insurance is a term that has legal weight. And the thing is that if you want actual insurance, you need like some kind of regulation around. That's why, like, for example, the Aave safety module is an answer to the fact that no insurance company in the world will insure the Aave smart contract. So the answer to that is to have like self-protection scheme exactly. From the community that are actually crypto active, actually decentralized, and I think this has weight. So we are lucky enough to never needed to use this safety module for the past 3 years, but the MakerDAO DAI Surplus, the safety module, those are like grassroots native ecosystem answer. But do we need to? Yeah, go for it. Sorry.
I would just caveat though. I think protocols like Nexus have done some great work, and they did have many examples where they paid out, and insured the space. I think the challenge is partly what Marcelo said, which is we just don't have enough data on protocols to price insurance properly.
I want to cover one last topic because we are running out of time. So very briefly, real-world assets. What's the percentage of Aave holding real-world assets in its treasury? Currently 0, probably, or?
The what?
Real-world assets?
Right now 0.
Yeah. Maybe just quick reality check on Enzyme, kind of the 0. Yeah. Gnosis DAO?
Well, around 15 million, something like this.
Oh, yeah, okay. Oh, I was expecting it was less, but okay, well, not too bad.
But I don't think, I think there is definitely space and room for RWA. I think it's just like a little bit, it's maturing now. We just
that was my question. So kind of,
but I think there's absolutely a place in a portfolio.
Right. So that was my next question. So what do you expect that number to be not 0 in 2-3 years, or do you think it's
0?
Okay.
Because, to me, it doesn't make sense for a DAO to hold directly real-world assets. But it makes sense for a DAO to have credit lines or partnership with treasury manager that holds the real-world asset on behalf. That makes more sense to me. And there's good synergy. But also, I think we are at the peak of real-world assets. This is the bull market of treasury stuff, and the thing is that it's not normal on risk-free treasury bonds to get 6%. Go back in time 2 years ago or 3 years ago, you were paying to hold this kind of product. 1 year from now, do you think you're still gonna take have 6% on it? So I'm not sure, like 2 or 3 years ago, that's gonna be such a huge market. It's gonna be a market for sure, but I'm not so bullish on it.
Cool, thank you. I think we are closing it here. Maybe open it up for 1 or 2 questions before we go into a break. Yeah, over there. Do we have someone with a mic? Yeah, I think right behind you.
Thank you. So earlier you mentioned the regulatory hurdles for DAOs to be compliant. I was wondering, have you ever thought about regulated trust companies providing services for DAOs so that they can be compliant with the jurisdictions as of now, or maybe different kind of corporate service structures? Within the context that this could be potentially a intermediate term solution, just like how Web3 auth is onboarding people through their email or Twitter account, and later them allowing to find out about self-custody, etc. So similar in that respect as an intermediate term solution. And maybe any examples of DAOs that are currently doing this?
You want me to answer? That was a question for me?
I mean,
yes?
I think whoever can answer or wants to answer.
So I will answer, but because Aave is decentralized, my answer is basically the answer of Marc Zeller, one of the DAO members, because that's not a decision from the Aave company or the DAO itself. You need a vote to have actually, and the voice of the governance to have actually like an answer that includes everybody. My personal opinion on it is maybe a bit tough, but I think having a mailbox on an island under the sun is not something we should aim for and say, oh, that's a definitive solution, and we have a strong man that we pay 20K or 50K or 100K a year. I don't think that's the way. We should be more ambitious than that. We should be, and I answer as the president of the DeFi committee of the ADAN lobby in France, that meet the regulator regularly, meet the French government regularly, and say, if we want to have legal representation for the Aave DAO or other DeFi DAO, it should happen in France. Like completely regulated in not a tax haven, whatever bullshit regulation, and have an actual status that can scale and be used for the next 20, 50 years and be a standard for the industry. So that path will take more time. That path will be much more complex. Maybe it's 5 years from now. Maybe it will never happen because the politician will never accept that. But I want to fight for this, and I don't want to take the shortcut. That's my answer.
Cool. One last question, or? Cool, then I think we're done. And having a break right now, but then see you after the break. Thank you. Thank you.
Thank you.
All right. Hello, everyone. This is the final section of talks for today. And to kick it off, we have Tammy Yang, who is a blockchain researcher specializing in on-chain analytics. Give a round of applause for Tammy.
Hi, everyone. My name is Tammy. And today I'm giving a presentation over a project that I'm currently working on. It's to build a risk assessment framework to assess stablecoin risks from different angles. And in the next 20 minutes, I'm going to cover the motivation and then the project goal. What are the different stablecoin risks being identified in the risk assessment framework? And what are the challenges of assigning an overall rating to stablecoin at the end? Yeah. Well, they're trying to fix the machine issue, but I can give a little bit background about myself. So, it's working. So about me, I'm currently working in a crypto exchange, specialized in blockchain analytics. Before that, I was a credit risk modeler for wholesale banking. And if you are interested in Oracle design, I also have a research paper being published recently. It's about relationship between on-chain and off-chain market data. And about this project, it's a personal project that independent from my current employer. I started about 6 months ago after receiving a grant from Ethereum Foundation, and it will be completely open source after it's done. So before getting into all the details about the different risks that exposed to stablecoin holder, I would like to review the 2 significant stablecoin events that happened in the last 2 years, because we're going to use them as an example when we analyze the risk. The first one is the famous fall of Tellor. So what happened is it started with UST slightly depegged after the market saw a large amount of USD deposit being removed from the Anchor protocol, as well as a large amount of UST being dumped into the Curve 3 pool. LFG, which is the Lunar Foundation guard, tried to recover the peg by selling BTC, but it wasn't successful. At the time, there are 2 ways to exit for UST holder. One is to sell UST to the Curve UST 3 pool, and then the other one is to burn UST by minting Luna. Then, if anyone has a little bit knowledge about how UST works, you know that it is backed by Luna, which Luna does not have any other use cases outside the stablecoin systems. So when UST's demand is up, Luna's price goes up. And when UST demand goes down, Luna's price goes down as well. In the crisis of confidence, more and more UST holders want to exit. And then, Luna and UST went into the death spiral. So just in a couple of days, UST and Luna UST's value dropped from $1 to below 10 cents. And then the next significant stable event was triggered by the collapse of the Silicon Valley Bank. In mid-March this year, then the SVB has been shut by the US regulator, and then all deposit withdrawal has been halted. Some USDC holder got worried because SVB is one of the custodians for the USDC's cash reserve. So they sold their USDC. as at the time it's not clear that what is the portion is stuck with SVB. USDC went DPEG, and followed by other stablecoin who has direct or indirect exposure to USDC. Like DAI is one example where DAI enable one-to-one swap for USDC to DAI in its peg stability module PSM. We also saw a run on the, so we also saw GUSD and USDP reserve in the PSM has been drained, which is shown in the diagram here. And then the Dune diagram shows the token breakdown for the Curve 3 pool during the DPEG weekend. Then you can see large amount of DAI and USDC has been dumped into the Curve 3 pool. So on Sunday, Circle revealed that only a very small portion of USDC's cash reserve is stuck with SVB. Then USDC's value starts going back. And then on the following Monday, FDIC promised that all the, they will enable all the deposit withdrawal for SVB. Then the USDC is back to $1. From the two examples we just went through, we know that the two general concern arises from holding a stablecoin. One is the risk that stablecoin significantly depegs and has a negative impact to the wider ecosystem. In this scenario, the value of the stablecoin may go back to the peg, like the USDC example we walked through. Or it can also be the case that stablecoin holder may suffer from the haircut. And then the second concern is the risk that the entire stablecoin project collapse. In this case, value of the stablecoin cannot be recovered, and that's the UST's case. And then the third concern hasn't been demonstrated in the two examples, but has been discussed quite frequently, is the risk of user being censored from using the stablecoin. That can be done by a centralized party who control the stablecoin. In this case, the value is there, but user cannot access to the value. There's many in-depth stablecoin risk analysis, but for common stablecoin holder, these are the metrics that they use the most, and then the most easily accessible. To compare stablecoin project, they use market capitalizations, circulating supply. And then you can have metrics that are not as easily accessible, but has been mentioned in many stablecoin-related discussions, like historical price volatilities, value of collateral, liquidity, and the incentive to hold. But if you think about the two cases, then for Tellor, the trigger of the Tellor, the failure of the Tellor, is because there's a fundamental flaw in their stablecoin system. They are under-collateralized by design, and they use Luna, which has a circular value that can go down to 0. And for USDC's temporary DPEG, they are fully backed by cash and cash equivalent. That's what people know. But its temporary DPEG was triggered by the custodian risk they are exposing to, which the custodian risk, the cash reserve exists as a banknote. So with all these metrics on these slides here, even the combination of them are not enough for analyzing stablecoin risk. So this is my project's goal. I call it SRAF, Stablecoin Risk Assessment Framework, to build a multi-dimensional stablecoin risk assessment framework to measure stablecoin risk from different angles. And then it's easy for common stablecoin holder to assess the information, and then easy for them to compare stablecoin risk. And most importantly, to encourage more risk-driven decisions rather than trend-driven or return-driven. The risk assessment framework further break the risk assessment into 8 different categories: asset backing, stability mechanism, governance, issuance and redemption, liquidity, smart contract, oracle, and regulatory risk. We believe that stablecoin, which has been assigned with the same risk values, exposed to similar type of risk. And then on a very high level, asset backing and stability mechanism are the two main areas have been used to describe how a stablecoin works. So in the rest of presentation, I'm going to focus on these two categories. But other categories are also important. The asset backing risk is the risk that the stablecoin may become under-collateralized when the asset that you use to back the primary value decline. So stablecoin project normally choose asset from one of the asset type here. Exogenous asset, which is the asset that have other uses outside the stablecoin system. Examples are Ethereum, Bitcoin, fiat, and other stablecoin. And then the other one is the endogenous asset, which the asset value arises from the stablecoin system itself, like equity in the system. Then the third type, some stablecoin used to have a design that was no explicit backing, and they rely on reward mechanism to adjust the supply and then to stabilize the price, but they are not here anymore, so I'm not going to the details of this category. For endogenous asset, the risk is that its value is derived from the stablecoin itself. When the demand is high, then the endogenous asset value is high. When the stablecoin demand is low, then the endogenous asset value is low. It will work when the market is good. But when there's crisis of confidence, the sell pressure on the stablecoin will trigger, may lead to both value going down together. So Terra is an example, but I want to mention that it does not mean all the endogenous assets are bad. So back in 2020, DAI did sell maybe 8 million of MKR to cover the shortfall. The fundamental difference is like in Terra's design, they use majority of its circulating value, majority of its primary value are backed by the endogenous Luna from the beginning. So when things happen, that all we know, they went into that spiral. So let's imagine like for a working stablecoin system, for every one new stablecoin, let's assume it's a US dollar packed stablecoin, new stablecoin being minted, then it's supposed to have $1 US worth of asset to be entered into the stablecoin system. But for UST's design, for every new UST design, UST is minted, then $1 worth of Luna is burned. In this case, supply down and Luna's price goes up. Luna hold a benefit from the newly minted USD. So it is almost like a bank is using client's deposit to execute a stock buyback. This is more details on the exogenous asset backing mechanism. They normally choose from this asset type here. So stablecoin choose TradFi asset will expose to traditional market risk, as well as the custodian risk and censorship risk that we learned from the USDT pack. And then some may choose other stablecoin to back their primary value. So it will expose to the risk that the other stablecoin, there might be bad thing happen to other stablecoin, like other stablecoin depack or other stablecoin has been seized by centralized party. That's what we learned from DAI. There are other cryptocurrency being used in the system. They are normally more volatile compared to the other two, and then used in the more often used in the leverage component, like Ethereum in Maker's MCD, or Ethereum in LUSD's Trove. This is an example of how the Swap framework assesses asset backing risk. We have 6 risk factors defined: types, whether this is a custodial or non-custodial stablecoin, asset type, as I just discussed. And then we also have asset breakdown. validation of real-world asset location, and information quality. Please note that the USDC asset breakdown is not updated. It's kind of outdated here. For USDC, how they validate their real-world asset is they have a monthly attestation and annual audit. And for USDT, they have a quarterly attestation. And for DAI, since they use tokenized real-world asset, I still haven't figured out a way to find out how they validate it. So more work needs to be done there. And then for asset location, USDC's reserve is with US banks. And then for USDT, it's unknown. It's maybe Bahama banks. And then for DAI, you have the asset on-chain, and then for off-chain is for the real-world asset. Information quality, depends on how valid the information provided by the stablecoin project. For DAI, it's high because some of the asset is on-chain, is all transparent. And then I haven't figured out for the tokenized RWA, so I put as a question mark. So let's talk about the stability mechanism. It is important to know about to analyze the stability mechanism of stablecoin projects so you know how they may fail to stabilize their value. On a very high level, stablecoin project use the reserve mechanism or the leverage mechanism to stabilize their value. They can choose either or use both. Stablecoin projects that use the reserve component in their design exposed to a similar risk, which is the risk that the stablecoin can become under-collateralized if the asset in the reserve component decline. Then for the stablecoin that also have a leverage component, the reserve component will help to mitigate the risk of short squeeze, but they will still experience the risk where if the collateral that used in the leverage component decline too fast, then the liquidation might become too challenged or too expensive to be executed. And then you have another type where you only have the leverage component. Then without the reserve component or without a negative rate setting, the stablecoin may have a risk to suffer from short squeeze, like the original DAI design before they have the PSM. This slide is about the governance risk. To understand what governance risks are stablecoin holder exposed to, you need to understand, firstly, who owns the governance process, how fast is the decision turnover, the level of decentralization and transparency, and what safeguards are there against bad governance. It is, for most of the stablecoin smart contract available, they are either controlled by trusted entity or they are upgradable, so that they can update their risk parameter later, or they can fix the smart contract if a programming bug has been identified. But it is also very important to have resilient governance designed to ensure that to prevent malicious player to have power to influence the decision-making process. For example, they make decisions to benefit themselves by harming other stablecoin holder. So the current governance design normally adopt one of the design here. One is a trusted base. That's for all the custodial stablecoin. They have a trusted entity to control the decision-making process. And then the other one is by majority vote, like the DAO. And then the third one is the interesting one, where all the parameters are already preset in the smart contract. So there's no room for them to change after the smart contract been deployed to the mainnet. In this case, it's good that there will be no decision. Malicious player can't really influence the decision making because there's no decision to be made. However, it has the witness that if smart contract vulnerability have been identified later, they can't change it. Liquidity can exist both off-chain and on-chain. It's very difficult to accurately assess the liquidity off-chain without knowing all the relevant addresses. But for on-chain liquidity, you can have code set up to monitor liquidity at centralized exchange. And these are the two diagrams I created for my dashboard to monitor the curve tri-pool token holding and then the Uniswap USDC DAI balance. These are the other categories that also in the define the project. So issuance and redemption, it determines the stablecoin supply. Smart contract risk, programming bug and logical error in smart contract. I didn't identify a lot. There's not much exploit to stablecoin smart contract as of today, but it is very common for other DeFi protocol. And you also have the Oracle risk, which is the risk of incorrect off-chain information being imported. And then at the end is the regulatory risk, the risk of changes in laws and regulation that may have negative impact to the stablecoin project. These are the past failure, a quick recap, and then most of them adopted a similar asset backing design. The challenge, I think the biggest challenge when you talk about stablecoin risk is how to assign an overall rating to the stablecoin, whether it's A++, 9 out of 10, 7 out of 10. The reason that is difficult because it's very difficult to judge the weight on different risk categories. And it can be biased depending on the person, the user's objective. And then it's also, there's not enough data to measure the probability of stablecoin default, so it's hard to assign score based on that. My concern is like having an overall score for a stablecoin, it might mislead a stablecoin holder that when they're using the rating, they're not aware of how the weight is assigned to each risk category. So our approach is to, rather than have to have an overall risk score, have a risk score for each risk category, and then the user themselves decide the importance of each category based on their own objective and risk appetite. Potential application can be help user decide which stablecoins they want to use based on the risk they are most worried about, help protocols decide which stablecoin to incorporate as collateral based on the risk the protocol that want to take or they don't want to take. And most importantly, stablecoin is one of the most important crypto application that can help to promote the adoption of the wider adoption of cryptocurrency in the general financial system. So it's very important to let the regulator to know that not everything is UST. There's a lot of good stablecoin design in the market. So this is what's more to come for my project. I will have a paper to list all the details, description of the chosen risk category, risk factor, and what metrics, how we use to measure them. Key stablecoin project overview, and then a doing dashboard, which is already done, to show live analytics that are used to monitor latest stablecoin market movement and on-chain activities. That's the end. Thank you.
Thank you, Tammy. We have time for 1 or 2 questions really quickly. All right, if not, then we'll get started in about 2 minutes with the next talk. Thank you so much, Tammy. Take care. Round of applause for Tammy. Alrighty, moving right along here. Next up, we have a talk from Georgios, who works for Gnosis, and he'll talk about Hashi today.
Is this the... Oh, yeah, here, right? Okay, thanks. Hi, everyone. So today I'm going to talk to you about Hashi. It's a framework we're developing with a goal for securing bridges by distributing trust. So let's look a bit the state of the bridges ecosystem. There are around or more than 30 bridges currently live on EVM ecosystems. They secure around 4.5 billion in TVL. And from a security perspective, vast majority is based on externally verified, so multi-sigs, MPCs, and such variations. There have been, of course, security issues, favorite topic when we discuss bridges. The last couple of years, 2-3 years, there's 2.5 billion lost in token bridge exploits. And in general, in the top 5 biggest hacks of crypto, 4 out of the top 5 are bridges. Out of these 30+ bridges that are around right now, the vast majority are multi-sigs or variations of externally trusted parties. And there is only a handful of optimistic or light client-based ones. So one could assume that maybe that's the issue, right? So let's look at some numbers. And this is a statement that many would say the last year, especially, that trustless bridges and L2s would actually solve this issue. Will they? So this is a list of, I believe, if not all, the vast majority of breach hacks that happen last couple of years. And we can see highlighted are the 20% of them, so 3 out of 15, related to compromised keys. So compromised keys, yes, it's an issue related to trusted external assumptions, so multi-sigs and MPC and several variations. But the vast majority of the hacks were not due to the multi-sigs, right? So they were due to smart contract bugs. Such bugs are very common in cutting-edge technology. So we should expect and prepare for such issues on both new trustless bridges and also for L2s. So the users, so this is what users are doing. We see clearly here that the L2s, TVL, so the user adoption there is growing, and there is a downtrend on the bridges. And of course, there's an argument, there is a reason to do so. But we need to keep a couple of points here in mind. So first of all, smart contract bugs on this new tech were not found, but yet, right? So the same was with bridges, by the way, till the first big hack happened. There is still single point of failure on this tech. So if there is one bug found in one critical smart contract, the whole bridge, and not only the bridge, but the whole ecosystem will fail. So one could say that, in general, reliance on bleeding-edge tech is not battle-tested enough. Let's look at also some learnings from Ethereum protocol development. It's stated quite often that client diversity is not optional, right? So here are so consensus and execution clients, there are different implementations, right? In different programming languages. Why do we do that? Why do we need multiple implementations of the same protocol? And are they, if there's just one, is this not dozens times audited? Is not enough? Here the answer is essentially that if there is an issue found in one of these implementations, in the compiler of a specific language, for example, in the Golang, then there would be a critical systemic risk for the whole ecosystem. And Ethereum has grown so much as a settlement layer that we take this little possibility very seriously. So one point here is that we want to start taking bridges as well with the same seriousness. So we need to look at the client diversity. And a key takeaway question here, maybe a rhetorical question, is it a higher probability of a bug in the Go compiler or in a highly complex math-based decay circuit? Some conclusions and observations from what we discussed so far. All bridge designs have trade-offs. There's no like good design and bad design or good bridge and bad bridge. Actually, there are bad designs, yeah, but there's always a trade-off. So every design tries to optimize for something, for security, for speed, for cost. Second point is trust in just one mechanism, in one implementation, is not secure enough, even if dozens of audits are done. So we need a more robust and resilient approach to securing bridges. And if we summarize all of this in a couple of words, is yeah, 100% bridge, secure bridge does not exist. So this is where Hashi comes in. And we build this framework with the following design principles. So security first and defense in depth. So we optimize for security. We focus on client, and in this context is security layer diversification. And we want to offer redundancy and protection against multiple issues. So compromised keys, malicious behavior, including governance, erroneous message passing, and of course, smart contract bugs. And we'll see how we'll do that. We call Hashi like the additive security approach. That essentially means that we base the cross-chain communication on, yeah, simple set, like multiple inputs, we call them oracles, adapters, multiple sources. The main goal is to distribute the trust, not to trust just one specific implementation of the cross-chain protocol, but multiple ones. And a third point, standardization. We want to offer standardization at the lowest possible level, which is the block hash. We want to do that because this is the only level where multiple cross-chain implementations, not only messaging bridges, but also light clients or oracles can basically work together. A couple of key features. So the framework is modular and agnostic to any kind of underlying mechanism. That allows us to plug there in general message passing bridges. Yeah, by the way, what is a general message passing bridge? Is you can think about like a wormhole, the Gnosis A and B, layer 0, Zeller, and Connext. Like all of these are message passing based. But also we want to use and integrate with light clients and oracles, even like Chainlink, for example. And allows communication at two different levels. So the block header approach, as we mentioned before, which is kind of a low level, but allows all these to work together. So like a light client can work together with a messaging protocol. But there is also a more simplified version where you can just use generic message aggregation. So get a couple of messaging bridges, not work with light clients, and just aggregate them and make sure that they give you the same answer. So here there's a clear trade-off, security and robustness over latency and cost. So clearly this approach is more expensive, is slower, but is far more secure. And last feature is like the two governance models that we offer, and I'll go into details yeah, in one more slide. The approach to defense in depth, what are our weapons to offer multiple times of defense in the security. So many different general message passing implementations. Any kind of bridge that offers a message passing mechanism can be integrated due to the modularity of the framework. Multiple light client implementations, M of N threshold. So imagine like something like a safe, like a multisig, right? So you can have I mean, if you want to optimize for security, you can have like a 4 out of 4. So you expect forces of input to agree on something. If you want to optimize for resilience, you can go 2 out of 4 and so forth. So you have this flexibility. And the last one is minimize the governance attacks by limiting the governance powers. And here I'll explain with a simple state machine what I mean. So this is not a topic not analyzed enough, but every L2, every bridge, I mean, essentially every system has a governance mechanism for upgradability, right? So no matter how trusted it is, most of the system, they have a multisig that can go upgrade the whole thing, change the configuration, kind of a admin thing, right? And the current best measures around in the market are delay on upgrades, like a couple of days or something. So of course we offer this approach. This is quite simple. But we took it a step further. We thought like, if we prioritize security first, we need to, look at this attack vector as well. And we want to minimize the governance powers. So what this state machine shows is you have a governance multisig, and you have initialization state, like you have to initialize the system, you have to give the initial parameters, what kind of bridges, oracles I want to use, what kind of thresholds, and all this kind of stuff. Then you have two operational states. One is the green one, so like normal operation, and we call it quarantine state, which is something is wrong, something gone wrong. So a multisig can, of course, initialize the system, and in a normal operation state, the governance cannot do anything, right? You cannot just go there and upgrade any kind of implementation or change an oracle or a threshold. But there are scenarios, and one can imagine a bunch of those. An oracle, a specific bridge does not provide any information. So it's like dead, is down, is hacked, whatever, or provides erroneous information. Or a light client needs to be upgraded, and so forth. So if such a scenario is triggered, then the system goes into quarantine state, and then the governance can, or the multisig can just, again, jump in, fix the system essentially, so change any oracles, adjust the thresholds, and bring the system back to the normal state where it has essentially no power. And here I want to show you now a kind of an end-to-end example of a token bridge, how it would work on top of Hashi. So we have to change to, that's here in this case is Ethereum and Gnosis chain. It can be any kind of EVM. How would you bridge tokens, right? So here we have, on the Ethereum side, in this example, we have two message passing bridges. One is Wormhole, one is our own canonical and Gnosis message passing bridge. And we have also two light client implementations. So what we're doing is we're not trusting just one of them. So right now we just trust A and B. In Gnosis, Polygon is the same, and and so forth. They trust their own implementation. So here what we do is we send essentially the same message through all of these oracles, which is the block hash in this case, because we work with the light clients. All of these messages go with different kind of security infrastructure and different models on the other side. And that is where we have Hashi and its governance module, where we have all this configuration we mentioned before. And if everything goes well according to our configuration, for example, 3 out of 4 of these oracles agree on this specific header, then I can consider this header or this message canonical. Therefore, it's safe to mint tokens. So we think this model offers a far more superior in terms of security model for bridging tokens. This is a more simplified version how to imagine Hashi. So it's based there's an analogy, right, with a RAID model, so in hardware drives. So you had 2 hardware drives that you store the same things, and if something happens to one hard drive, you can rely on the other one. So same concept here. So you can say that Hashi is like a redundant array of hash oracles. So you essentially have the same, you ask for the same information, for the same input from different sources, different implementations of cross-chain protocols, and if one is compromised, is down, you can rely on the other. What's Hashi's current state? So we have a testnet live and 5 integrated oracles from the ones I mentioned before. So if you're interested, you can go check it out, play around. It's on Girly and Gnosis chain. And of course, if you're developing something or if you have ideas, feel free to reach out. So, and in progress, we have several interesting applications. Some of them are in early stage, some of them in later stage, such as cross-chain safes, governance use cases, cross-chain swaps, And of course, the token bridging I mentioned before. And I want to show you a little bit from the examples I mentioned before, I think they are quite vanilla, and this is a bit more exotic. So what are the cross-chain safes? So you have, here you have Ethereum and you have Gnosis chain. And you have the main safe on Ethereum mainnet, and you have a secondary safe on Gnosis chain or anywhere else in any other kind of EVM chain. Using Hashi, you can essentially control the secondary safe on Gnosis chain without doing any transactions on mainnet. We know like mainnet is expensive, for example. You don't want to do a lot of transactions there. So how is this done? You use Hashi to bridge the state of the chain of Ethereum to Gnosis chain in the most secure way possible. And over there, you can perform some proofs and essentially control your secondary safe using these proofs just by transacting on the secondary chain. And what's next? So apparently, it's mainnet deployment. So we are quite ready to deploy in mainnet. We're also growing the team and working further on that. In terms of diversification, as I mentioned multiple times, this is the main value proposition here. So we want to keep integrating more oracles, more bridges, more implementations. Also, not only on the security level, but also on the execution. So on the message passing. So before we focus mostly about how do you bridge state, but there is also the message passing mechanism, like what do you do with the state? How do you execute messages? And there can be issues also on that level. So we want to have multiple implementations on that level as well. One of the biggest milestones is to get the Gnosis Omni Bridge as is right now and upgrade it and secure it with this model, which will upgrade the security of the whole chain, essentially, not only the bridge. Expansion to major EVM ecosystems, and also not EVM, but it is quite easy to do. Eventually offering secure assets, with the example I mentioned before, and also cross-chain governance use cases, which is something that we've seen. Many DAOs have been exploring this, especially last year. And that's it. I mean, I want to mention here that we're hiring. If you guys are interested to work on that, feel free to reach out either on Gnosis side directly or to me. And also we can, if you have any questions, can.
Thank you, Georgios. And we have about 5 minutes for questions here. Any questions for Georgios? So right here and down in front. We have a microphone for you.
I was just curious if it makes, given the additional verifications on the bridging, if it makes the bridging more gas intensive, or if it has any impact on like the cost for the user to bridge?
Yeah, very good point. Totally. So again, there is a clear trade-off here. So it's a part. It can be in theory 4 times more expensive if you use 4 oracles. And one challenge that we see is, okay, bridging outside from Ethereum to any other chain, it's kind of manageable. But then anything that goes back to Ethereum mainnet, especially updating ZK Lite clients and stuff, is extremely expensive. So we're working towards improving that and finding solutions because yes, it's quite expensive.
Over here on the right-hand side.
Thanks for the talk. How will you deal with varying bridging times? Will the slowest bridge determine when this oracle can give an answer? Can you elaborate on this?
Yeah, that's a very good point. So Hashi is essentially as fast as its slowest oracle. And if in our testnet, we're looking exactly this problem that you have message passing bridges which are super fast. Like Wormhole, for example, is super fast, or our own A and B, and then you have light clients which are a lot slower. So a light client, I mean, in the current testnet we have, it takes 30 minutes. So like bridging the state, computing the proof, submitting the proof, verifying the proof. So yeah, there are improvements being done by the ZK Lite client teams implementation. This is a super early stage technology. We expect, honestly, that there will be improvements by the Lite clients themselves, because this is what slows the whole system down. Other than that, the system is so modular, so you can also customize it. And because Lite clients is like again, additive security, but if you cannot afford at the moment that they are that slow, you can focus on multiple message passing bridges and get rid of the problem.
There was another question over there.
Hi, thanks. Okay, sorry, I'm a bit quiet. So, your solution, is it not moving the risk from multiple bridges, like, okay, each of them has their own risk, but then you somehow aggregate them? Won't the risk be there? Or are there multiple, like, are those the different implementations you were talking about?
Yeah,
Thank you.
That's a very good point. So you're right. I mean, what we're doing is like we're aggregating. So we have different kind of implementations. By implementations, I mean, by the way, different general message passing protocols, different oracles, right? Different Lite clients and stuff. So yeah, essentially the risk is transferred to Hashi. What we do to minimize this risk, number one, Hash, if you look at the code base, is a very thin layer. So yes, it's not like the most complex code base, at least at the current state. So it's super modular. So if you want to strip it down and just focus on something that is super well, again, audited, understudied, and secure, you can do that. There is indeed risk there. But I believe also the governance in my opinion, governance was worse than that. So even if you say, okay, I can trust. Yeah, there's a bit of oxymoron here since of the topic of the talk. But if I can say, okay, the hash layer is super thin, and I can work with that. If you have a governance that is a multisig that essentially can go anytime and replace oracles or change thresholds, this is your single point of failure. This is why we started working on this alternative governance system.
We have time for one more question. If not, then I think we'll wrap it up there. Thank you so much, Georgios.
Thank you, everyone.
We'll take a short break and then get started with the next talk. All right, moving along here. Our next talk is from Togro Maharamov. I'm sorry if I mispronounced that, I'm sure I did. From Scroll ZKP. Scroll is the native ZK EVM. Give it up for Togro.
Hello, everyone. My name is Togrul. I do research at Scroll. You can mostly find me complaining about things on Twitter. Well, this week I was suspended for a few weeks. Now I'm back complaining. And today we're going to be talking about EVM-based rollups. So everyone is building EVM-based rollups these days, but what's next? Like, why do we even need them? So you've probably heard about rollups. Everyone's talking about them these days. And you've probably heard that they're an ultimate scaling solution, how they scale Ethereum to gazillion transactions per second, how they offer unlimited scaling, how they allow you to have arbitrary execution environments, blah, 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 blah. They even cure cancer, apparently. No, they don't. So yeah, but rollups are actually exciting. I'm a bit biased here because I'm working on a rollup, but yeah. But is everything that we talk about realistic, or do we just get too overly excited and forget about certain technical details that we have to mention when we talk about rollups? So for now, let's assume that Ethereum has unlimited data availability, so rollups are not bottlenecked by data availability. And just to explain what data availability means, in this case, regardless of how much demand there is to post data on Ethereum, Ethereum can always handle it. Let's just assume that that's the case for now. It's not, but in an imaginary world that we're trying to describe here, it is. So let's also assume that we've built an EVM-based rollup. Specifically, it's even better if your rollup follows the similar patterns to Ethereum in terms of state storage, execution, et cetera, and even better if your rollup client is based on a modified or a vanilla fork of Geth, Aragon, Nethermind, or any other execution client for Ethereum. So an example, Arbitrum, Optimism, Scroll, Polygon, ZK VM, ZK Sync era, and et cetera. You can think of Base, Mantle, et cetera. So in this case, Polygon and ZK Sync have their own clients that are similar but are a bit different to the existing clients. And Arbitrum, Optimism, and Scroll fork and slightly modify Geth, and in case of Optimism, also Aragon and Breath, I think, but it's not live yet. So raise your hand if you think that Ethereum is bottlenecked by the consensus. Good? Good. Glad nobody raised their hands because you would have been wrong. And I presume that nobody works at Avalanche here. That's why nobody raised their hands. So Ethereum is actually bottlenecked by the read and write operations. So what that means is Ethereum's state is stored in a structure called modified Merkle-Patricia tree. And just think of a state as a union of all the non-empty user accounts and also smart contract accounts. So for example, the account that displays your balance, the Uniswap router contract, et cetera. All of those accounts that are deployed on Ethereum, all of them constitute this one state. And it's stored in this structure called Merkle-Patricia tree. And it's called the Merkle-Patricia tree because it's modified, so it utilizes hexary branch nodes. So what that means is instead of having a branch that points to 2 children, it points to 16 children. It's Merkle because it recursively hashes the child nodes until we get to the root, so think of Merkle trees. It's Patricia, also you can sometimes refer to as Razdik tree because it merges single child nodes with their parent nodes, so think of it this way, if you have a node and it points only to one child node, then you can just merge them together and basically use an index to traverse and skip those single child nodes. And it's a trie because it utilizes the leaf position to define the associated key. So in Ethereum, for example, if you traverse through the tree and get to the leaf, the traversal path represents the key where the account data is stored in this case, or the specific slot. And this is a good representation of how it works. It's a bit confusing, but you can see the extension node is what I described. In Patricia tree, then you can see the branch node has 16 values instead of 2 values. You can see that the leaf can have a prefix, et cetera, and you can see that it has a value. It's a bit simplified in this case, and the value is basically what is referenced here through the keys to get to the leaf node. So back to the subject at hand. It was a bit, we went on a bit of a tangent. So read and write costs rise as the state expands. So the reason why that is since there are fewer extension nodes as the tree grows in size, we need to get more, we need to go through more reads in order to get to the leaf. And assuming that at some point your tree is completely filled, your state is completely filled, you get to the point where your reads and write cost will be equivalent or double in case of write, because you need to rewrite it back to the depth of the tree. So assume in this case the depth of the tree is 160. You'll need to do 160 hops through the storage in order to get to the leaf. And for some information rollups, it's even worse because they start with the worst case scenario. So for example, in Scroll's case, we use a structure similar to a Merkle tree. So for us, your starting point is basically the worst case scenario when you have to do the maximum number of reads. And the same is true for zk-sync and Polygon zk-VM. And Ethereum is purposefully rate limited to slow down the rate with which the state grows. And rollups can set the, of course, the rollups can set the limits higher, but you can think of it this way. You can increase the hardware requirements at the limits higher because you don't need the same level of decentralization as you have in L2, but there's always a limit to it. So, and you can ask the validators from Binance Smart Chain how well that goes when you just raise the limit and just don't think about the outcome of it. So just to give the context here, at some point, Binance Smart Chain used a fork of Geth, and at some point, because the limit was so high per block, the validator nodes couldn't catch up with the tip. And so there was, at some point, there were literally almost no nodes in the network that could catch up, no matter how high-end the hardware they used. And so at some point, they switched to Aragon, and now it's better, but it's still, but they lowered the gas limit because they realized that it's not very tenable. And so what is the solution? Well, there are a few solutions here. One sort of a solution, it's not a complete solution, is stateless clients. Stateless clients outsource statefulness to specialized operators. So think of it this way. You have a few nodes in the network that store the state, and the rest don't. The way it works is basically with every block produced, those nodes that have the state just attach the openings to the tree that have been written or read. And then every other node that doesn't have the state, just has the state root, can just trustlessly verify that the state is correct. And the advantage here that stateless clients are still completely trustless as long as you provide them with the witness data. And there's no additional trust assumptions, etc. But there are a few problems here. One, it requires a switch from Merkle-Patricia trees to, for example, Merkle trees. And the reason is, with the way Merkle-Patricia's trees work, the data requirement to propagate the witness in the worst case scenario will be impossible in the current network settings, which means that you'll end up with a network that would just stall at some point and not work. And another disadvantage, oh, sorry, there are no other disadvantages here. So another option that you can use is state expiry. So state expiry is, in its current form, there are a few different versions of it. So in the current form, once per epoch, you just prune the state, start with a new state, and then store only the state roots for the previous epoch. The currently proposed, at least the latest variant that I've read, the epoch lasts around a year, so it's different to the epoch in the Ethereum consensus. And you can revive the pruned state later. So essentially, you can include a transaction that says, here's the opening to this root in this previous pruned state that you have the root to. Please add it to the new tree. And then you can just revive it and transact. But the problem here is that the advantage here is that it limits the state required to store by the full nodes to a certain fixed amount. So let's say you can assume that you can set a certain gas limit and you can have the state of a maximum size per this epoch. I don't know, let's say 60 gigabytes or 1 terabyte or whatever you can think of. And it can never grow larger than this because you just prune the state, have it stored somewhere, and then if any nodes need them, they can access the archive nodes or use some kind of an infrastructure provider like Infura, et cetera, to fetch the data and then revive the state if needed. But there are a few disadvantages here. So the main disadvantage is that it requires the extension of the addresses to 32 bytes. And so, which is not really an option for Ethereum right now because Ethereum uses 20 byte addresses, and therefore it will break a lot of the contracts. And the reason why you need 32 bytes is because you need to store the epoch at which the certain account was stored. So let's say if the account was first stored at the current epoch, when the next epoch comes around, by looking at the address, you just know that you can prune it. And you could do it in another way, but it's sort of a problem, and that's why it's, at least at the moment, it's difficult to see how it will be implemented by Ethereum. And then another problem here is that it requires changes to the EVM. So think of it this way. So for example, you're executing a transaction, and the transaction tries to touch the slot that was pruned, and it hasn't been revived yet, which means that it's inaccessible to the full node. And therefore, there needs to be a way to handle those errors and a few other things as well. And so we need to change how EVM behaves in these scenarios. And there's another possible solution, which is just using some clever tricks. So for example, in Solana, the state is Merkleized only once per epoch. And again, this epoch here has nothing to do with Ethereum consensus. You can think of a different number. I think in Solana is like once every 2 days, but whatever. So essentially, it makes the real-time read-writes costs constant, whereas in Ethereum, the read-write costs are ON, where N is the depth of the tree or the particular slot that you're trying to touch. And that means that you get really fast storage in real time. Well, it sounds like a perfect solution, but it's not. One, it makes light clients and stateless clients almost impossible to build. And the reason is because you Merkleize the state later, the light client cannot trustlessly access the latest data in the state, which means that it either has to wait, or Solana does this weird thing where you can send the transaction to check whether a certain slot is equivalent to a certain value, which basically asserts it, and if the transaction returns true, then you're actually good, and you know that it's a workaround, and I don't think it's ideal, because as long as your transaction is not lost in the last block that you read, there's always a scenario where that slot could have been modified later on. And another problem here is that you can't really build provers for that, nor fraud proofs, nor validity, so zero-knowledge provers. And the reason is because to construct proofs, you need a succinct way to prove inclusion into the storage. And there's just no way of doing it here, which means that you have a system that cannot be a roll-up, essentially. And let's assume that we solved the state-related bottleneck. we managed to use the clever trick that I described somehow, figured out state expiry, et cetera, what's the next bottleneck that we need to solve? The next bottleneck is sequential execution. So in Ethereum, the transactions are executed sequentially. So what I mean is you pick a set of transactions, you execute one, you wait until that one is executed, then you pick the next one, execute it, wait for that to finish executing, apply the state, and then go on forever, which is not really a problem in Ethereum because the gas limit is so low that it never really affects the speeds per se, because you never required that amount of execution. But assume that we solved that problem, so now your gas limit is very, very high, and then you actually need to parallelize execution. So what are the solution here? So you can optimize it through parallelization, and there are a couple of ways you can do it. One, you can do it optimistically, or you can also do it deterministically. So an example of optimistic parallelization is block STM. So think of it this way. It optimistically picks the transactions from a mempool, executes them, and then if it discovers contention, so for example, 2 transactions are trying to write to the same slot, it reverts to sequential. So in the best case scenario, you get a significant improvement, and essentially you can scale with the number of cores in your system. And it requires no to minimum changes to the state transition function because it's done outside. So if it fails, you just revert back to sequential. But the problem is that in the worst case scenario, or even average case scenario, where a lot of the transactions touch the same slot. So for example, if a lot of transactions in a given block try to use the same Uniswap pool, this will just fail, and it'll add even additional overhead relative to sequential execution, which is not ideal, but is there really an ideal solution? And the second option is deterministic, where you require the application to declare, the transaction to declare all the slots that you've read and written to via an access list. So Ethereum introduced this thing called access list. It's currently optional, so you don't have to use it, but you can make it mandatory as well. And essentially, you parallelize by picking the transactions that declare non-overlapping access lists. So for example, if transaction A declares that it touched slot X, and then transaction B declares that it touched slot Y, you know that they'll never overlap, and therefore you can trivially execute them in parallel. So it introduces no overhead relative to sequential execution in the worst case scenario, because in the worst case scenario, you just execute it the way you would execute the sequential. But in the best case scenario, it scales with the available cores in the system. And basically, the more cores you have in the system, the more transactions you can batch and parallelize. But there's a downside here as well, unfortunately, that the transaction outcome has to be deterministic at the time of its creation. Because you have to declare the slots, and they have to be declared in advance, it's impossible for you to later touch a different slot. Which means that, let's say if your transaction execution path relies on some conditional statements that touch different slots, it will just fail in this case, and you would have to resend the transaction again, which means that you either have to be lucky to have your transaction included, or just compute multiple transactions with different paths, which can get very complex in case your transaction has your execution path has a lot of conditional statements. So unfortunately, not ideal as well. So yes, rollups are great, but there's still a lot of work ahead of us that we need to make for us to make them actually scalable. And so thank you for listening to my talk, and feel free to ask any questions if you have.
We have time for a few questions.
Yeah, of course.
Over here. We have a microphone for you. Just 1 second, sorry.
Sorry, no problem. Hi, thanks for the talks. Just have a quick question. So when you were discussing the cost of IO, you were really talking about the cost of updating the state tree, I guess, right? And you were mentioning that this is proportional to the depth of the tree. And then my question is, regardless the stateless client, wouldn't you have a similar scaling? Maybe not in IO cost, right? But in computational cost, in the sense that as your state grows, then the computation needed also grows logarithmically in the same way, right?
No, because you can just because the witness size is relatively small, you can just put it into the RAM and access it really quickly. Whereas with the state, if it grows really large, you cannot store it in memory, so you have to put it at least parts of the state on the disk, which means that it's not very fast. And on top of that, the problem here is that you basically have to jump through the slots in the memory, even if in the ideal case scenario, to reach the point where you can read the leaf. Whereas in this case, you would just load everything in one batch and would just read it sequentially. So you don't have to go through different points on the disk, et cetera, et cetera. So while there is certain overhead here as well, it's not even comparable to having a stateful client.
Another question for Tagro? All right, if not, we'll wrap it up there. Thank you so much, Tagro. A round of applause. All righty. Up next, we have a talk from Igor Mandrigan from Gateway FM. Gateway is building the next generation of Web3 infrastructure and tooling products. Give it up for Igor.
Hi, everyone. Hope you can hear me quite well. Yeah, my name is Igor, and I'm the CTO and co-founder of Gateway FM. Before coming to founding this company, I've been a core dev at Ethereum for a while at the Aragon team. If you heard the previous talk, there was quite a lot of talk about the stateless clients, so I worked on those for a while. Now we are also working quite a bit on Polygon ZK EVM and Gnosis chain. We are kind of providing a lot of infrastructure towards that. And today I want to actually start with like a tiny demo, and then to give you a little bit of context for this demo. So I'll just exit my presentation. We'll switch here, and we'll do 1, 2, 3 clicks, and go to the dashboard. And what I did right now is I basically started creating my own ZK rollup on Ethereum Cipollea. So now we can go back to the slides and hope that it will actually finish provisioning by the end of my speech. So we'll see. And basically, why did I do that right now, and why did we do this service? So we always were thinking at Gateway about the good future for crypto. We founded this company back in early 2021, late 2020. And back then, if you remember, the majority of the Ethereum nodes were in AWS in North America. And we wanted to make an alternative towards that. So we made an RPC provider that explicitly didn't use public clouds. It was reliant on private data centers. And these data centers were also located in European cities, and we had a couple of them in Sweden, a couple of them in Switzerland, some in Germany. Then we added some more, and that was because capturing all the nodes by the same entity, like AWS named, or in the same legislation, is really, really dangerous. It can kind of give the future that's not really good for crypto when there's just a single entity controls everything, right? And right now, in 2023, the situation is much, much better. So we have plenty of infrastructure providers all over the place, from Singapore to Europe to the States, of course. And but now we are going to the next stage of the future, and that's about adoption. And I think, we've been talking about adoption since forever. Like when I just joined the kind of Ethereum movement in early 2017, everybody was talking about bringing the next billion, getting mass adoption and stuff like this. But right now, it's a bit of a unique thing when we finally have some legislative clarity, at least in some areas, about crypto, and a lot of people are thinking about how to integrate blockchains. And we can kind of think a little bit about of those people in two categories. So one is that I consider myself in, is kind of a crypto native people who are coming from kind of a principled background, who understand how the tech works, and they are already using the good parts of crypto, some extra freedoms it provides, some extra features, some agency. And then, to be honest, this part is kind of in the minority right now. And then there is the second big group of people who are interested in the blockchain somehow, and those are enterprises and institutions. And theoretically, these groups of people can influence much, much more people than just a group on the left. And if we see what's the difference between these groups are, so I would say that it just, of course, I'm simplifying quite a lot here, so don't get offended if you consider yourself in either of this group. But if we were talking about Web3 natives, we're talking about that kind of this censorship resistance, open for everybody, permissionlessness and other principles like this, like privacy, yada, yada, yada. And if we look at the big companies, like any big company, and maybe if it's a government agency or something like this, the first thing they want is to have control because they are afraid to let things go because they're afraid to get in trouble. And the second thing they want is to basically be flexible, to have somebody who can tune these things, tune these dials somehow for them, again, to feel in control and safe. And we want a good future for crypto when as many people as possible are using it for, like, to be more open, inclusive, neutral, without censorship and stuff like this. And I think right now we can kind of at a unique phase when both enterprises and Web3 natives can finally come together in a good compromise. And I think it's all related to ZK technologies. Of course, again, ZK is the thing that we've been talking to, and it was a hot topic for quite a while, right? Probably a couple of years already. It was one of the hottest topics. But we only this year, we got finally the first serious deployments of this in production. So only right now you can come and just show that, OK, it's not just a proof of concept of a proof that lies at a 5 megabytes JSON file on my computer, but there's also the whole system, like the ZK rollups, like of ZK Sync, of Polygon, that actually take these proofs, verify them, use them in the sync, use them in the bridges. And why I think ZK can power something good. So to me, the future probably will look somewhat like this. And the good future will look, for me, would be when we have really good layer ones, like Gnosis chain or Ethereum, that are spread around the globe well, that have like huge, vast validator sets that cannot be captured by like a single entity. And then we do a lot of kind of a customized layers on top of that. And that's useful because these layers will still give the sense of kind of a control and flexibility towards enterprise and government users, for instance, but they will still be settled on Ethereum or Gnosis chain, on this kind of neutral network that are built with principles that the community always had, right? And how will DK actually help with that? And that's a really good question. And I wanted to just tell a little bit about the user agency in ZK rollups. And to talk about it, basically we need to talk about what is a ZK proof, what does ZK proof proves in a ZK rollup. If we're talking about just a normal blockchain, we have the consensus that verifies that every transaction, it kind of satisfies a certain set of rules. These rules could be that, oh, your signature is valid, the money that you transferred you did have on your account, so, or the asset that you own is actually your asset, and yada yada. There's a lot of rules like this, and there's just generic rules of EVM. And what does the layer 1 do? They basically take all the transactions, and every node re-executes this transaction, and basically they validate this proof by just re-executing, because if somebody malicious does something strange, your node just will not take this transaction. It will reject because it will have another result. In ZKL2, the same set of rules is actually, yeah, it's being tested and verified by the ZK proofs. So there is a ZK proof that generates that every transaction that since Genesis happened on this layer 2 always were adhering to this set of rules, plus the rules of the EVM engine. And they generate a proof. But the important part here is that this proof is then getting verified on an L1. Right? So it's not L2 generates this proof, and it's kind of challenges L1. And L1 has actually this script that checks that the proof that you gave to it actually adhere to this, all of these rules. And that means that in this case, layer 1 has a big influence over like a layer 2 operator, because what's happening on layer 1. Basically, let's say if I'm a malicious actor and I want to tweak something in my rollup, then it's mathematically impossible for me to get a proof that will be accepted by the layer 1. And what's important, the verifier of this layer 1 is very tightly connected to the bridge. And then if you are, as a customer, like sending transactions or you're locking your ETH into ZK-powered bridge, that means that if there is a malicious agent on another side, it has way, way less power over you than like in a normal case. So that means that if we have good layer 1s, very distributed, really nice ones, then it means that with these ZK technologies, we can bring quite a lot of these properties of user agency to the layer 2s, regardless of how decentralized they are. And again, for institutions that want control and stuff, they will unlikely be really decentralized. But there is a problem, of course, that, of course, the good future is ZK, but it's not always that the best tech is the tech that wins the market, right? To have a chance to kind of compete on this market, your tech should be convenient, primarily. We see this quite a lot, let's say, with JavaScript nowadays. I don't know if you're all front-end developers and will hate me right now, but I'd say that JavaScript was never designed to build desktop applications from it or to build mobile apps from it, but since it was really convenient with a good developer documentation, with the good tools around this one that actually won everything, and now every second app on your Mac or on your Windows is Electron, and every second app on your phone is React Native. But that means that the tech needs to be convenient. And also, I would say that this tech, it actually needs to be built by somebody who cares about principles. So because if you can encode those principles very early in the tech, and then it's very convenient to use, so enterprises and institutions will use it, that means that these principles will be, for these enterprises and institutions, very hard to change afterwards. And that's where my demo actually finally comes into fruition, because what we are building right now and what we're announcing right now, and actually launching, not just announcing, at Gateway is the thing that we call Presto. And it's a next step into what we call the good future for like blockchain community. Basically, right now it's a building block when you can create your own ZK rollup in minutes, which could be public, semi-private, but they still will settle on Ethereum or Gnosis chain or similar chains. And we are kind of in the unique position because we are also contributing quite a lot towards ZK EVM implementation. So yeah, we know what we're doing. So let's see. And not only there will be not only just the rollup. Of course, you can pick where you put your stuff. Maybe it's AWS, maybe it's a private data center, maybe it's some of the public clouds. You will get managed RPCs from there. You can get custom fee model. You already get a bridge. And like a lot of, we are not trying to kind of do it just by ourselves. We are having on board quite a lot of partners. So these are the partners that we already talked to and discussed. There are some, because to build an actual useful thing, you need to bring a lot of technologies together to build it. And it might be like a KYC, it might be some data availability stuff, oracles like Redstone, maybe some NFT APIs or automations like Gelato, and of course, something like for account abstraction like Gnosis Safe. So basically, this is a little bit of how it looks like, but let's see if my rollup actually did provision. So yeah, it did. So you see it here. So I started it about, give or take, 13 minutes ago. And now it's live rollup on a ZK EVM rollup. Oh, sorry, ZK EVM Validium on Sepolia. And you can do the same if you go to our website and just, well, I'll do the worst thing that our team will hate me for. I'll try to actually test that it works. So let's see, I have this thing here, which is just a valid address. And let's see if the faucet oh yeah, the faucet works for sure, because it's a testnet, and you can go to the block explorer already, and you have the first transaction of 1 Ether to the address I sent. So it's actually a live L2, like provisioned within like 13 minutes and 3 clicks. And that's what I'm talking about, that the tech should be quite convenient. So today, you can go to presto.gateway.fm and just repeat what I did and try to get your own ZK Validium running. It's going to be free, and since it's free, you will not have a real working prover there, because they are too expensive right now to give out for free. So if you want a real prover there, then you can contact us and we'll provision it. We also can provision mainnet. So far, it's only through contact us forms. Later this year, we are planning to launch mainnets as well, with the billing where you can use your crypto or credit card or invoice, normal business invoicing. If you want to see some updates on this, you can always subscribe to our Twitter or X right now for the updates. And then you can always, yeah, as I told, you can try it now. I think you can create one for free. Of course, it's a beta launch. It's a test, so you might break it as well. But that's it. So I think that's what I wanted to say. And let's leave a little bit more time for questions.
Thank you, Igor. We have a few minutes for questions. We have a question up there. We have a microphone. Just give us 1 second.
Hey, very cool presentation. Thank you. I was wondering, obviously, Polygon ZK EVM is really cool, but recently we saw a lot of adoption from OP-Stack, like a lot of projects launching there. Do you think choosing ZK EVM is a bit like leapfrogging, beaming us straight into the future, or where do you think OP-Stack sits here?
I mean, I think OP-Stack is a good intermediate step, but what's the big difference between, like, in general, optimistic rollups and ZK rollups, and why I think it's important that ZK rollups the ZK rollups provider has to provide a proof that every transaction on the chain is actually valid according to the rules, like every transaction, regardless of what's happening. And optimistic rollups, they kind of think that's all right. Everything is OK unless you challenge us somehow. Of course, this challenge could be with automated as well. But still, I think to me as an engineer, it's a much, much more neat solution when you actually, I am as a potential malicious entity, will have to prove to you that I didn't break the rules. I think it's much better than you trying to catch me red-handed or some third entity trying to catch me red-handed. So we really like ZK rollups. And why we choose in particular the Polygon ZK EVM is that was the only something that you can call a ZK EVM in production at that point in time. And we actually did quite thorough testing by taking an Ethereum node, ripping off the Merkle tree, putting the same Merkle tree that Polygon ZK EVM had, and running this the whole Hermes or Polygon ZK EVM mainnet on like a vanilla EVM. And then the root hashes actually did match. So it has a pretty good bytecode compatibility. We didn't find, apart from what's written on their wiki, we didn't find any big differences in how bytecode is interpreted. So it's a pretty cool achievement.
I saw another hand over here.
Yeah, thanks. Maybe to continue a bit on what you just said, a bit of a general question. Can you make a couple of comments on the current state of ZK rollup technology in terms of how big are the proofs, how long does it take to process a proof, and yeah.
Yeah, it's getting better. Like right now, we have something that can be in production that can actually prove something like Ethereum blocks or layer 2 blocks every, let's say, 30 minutes to an hour, like everything in them, using these recursive proofs and stuff like this. It's still very expensive to run servers that can do proving. And, but let's say right now, to run a prover, and we have our head of infra here, and he can correct me if I'm wrong, but you need to have like at least half a terabyte of RAM. That's the absolute. Okay, 700 gigabytes of RAM. You need like a server for that. It used to be that it was over a terabyte. So it's getting better, and with the new technologies, with thing that's, at least the guys in Polygon called variable size state machines, it will be even better. But so far, yeah, to make it, so far it's just expensive, but it's, I think it's good. Yeah.
Any other questions for Igor over here?
Yeah. Thank you.
I believe you mentioned that so far the project is active on a testnet. I was just curious if you have any stats you could share on projects that showed interest in using this tool to ship their own app-specific rollups and.
Yeah, we have a couple. Like again, it was opened, kind of opened, and kind of first version was launched basically today. That means that we don't yet have any stats on this version, but we have the previous version when we semi-manually were provisioning rollups, and we have 2 interesting customers. One of them is called Gnosis Pay, that is currently running in a very kind of old installation on OP stack that we provisioned way back in the spring, right? And then we have another, it's called Palm Network, which is a kind of NFT-based network where we are doing the transition of them being this private chain on Hyperledger Bezo into a ZK rollup. So these are 2 clients, and we're talking to a couple of more, but those I cannot share.
Time for one more question. If not, then let's give it up for Igor. Thank you so much.
Thank you.
Okay, hold on 1 second. Let me just. Alrighty. For our next talk, we have Vijay from Specular, an EVM native optimistic rollup. Put your hands together for Ye.
All right. Hi, everyone. I'm Julio. I'm a co-contributor of Specular and also a PhD student in Berkeley RDI. So today I'm going to talk about towards secure, trust, minimized, optimistic rollups. This is the overview of today's talk. So first, we are going to review the current optimistic rollups, and I'm going to talk about the security and decentralization challenges in the current today's rollup. And I'm going to talk about our solutions to solve these challenges, including the methodology and the system we're building, Specular, and EVM native optimistic rollup. And then I'll share some development status updates of Specular. So first, as we all know, Ethereum does not scale well. So it has low throughput and high gas fees most of the time. So the question is, how can we scale Ethereum's throughput without compromising decentralization? So optimistic rollup is today's successful scaling solution to Ethereum. So instead of executing the transaction on-chain, the sequencer will sequence the transaction on-chain, but the executor will execute them off-chain. And after execution, the executor will propose a new state root of L2 on-chain, and other executor can check this state root. And if they find this state root is invalid, the executor can submit a proof to reject this state root. And if there's no challenges after the challenge window, the state rule will be accepted. So in practice, there's a massive liquidity in optimistic rollup. So that's why the reason we want to make it more secure and more decentralized. So in modern optimistic rollup, they tend to achieve these objectives. So first, they want low-cost normal execution when the sequencer only sequence the transactions. And also, they want reasonably low-cost and bounded disputed resolution. And most importantly, they want identical developer experience to L1. This includes, first, same execution semantics and instruction level. So you don't want a custom VM that's simulating the EVM. And second, you want minimal to no changes to L1 contracts when redeployed at L2. So these properties are often referred as EVM equivalence. So both Aavechan and Optimism today takes an approach called compiled approach, which perform interactive fraud proof over a compiled L2 client binary, where the client consists of a custom L2 specific consensus clients, which are in charge of a derivation pipeline, etc., and the existing but modified Ethereum execution layer client implementation, for example, the Geth. So in case you don't know the interactive fraud proof, it's an interactive protocol for the challenger and defender to narrow down the dispute into a single instruction, depending on the compiled VM. So more concretely, in this compiled approach, they compile the L2 client into lower level target VM. For Aavechan, it's WASM, and for Optimism, it's MIPS. And they commit to the resulting binary on L1 using a vector commitment, like, for example, the Merkle tree. And therefore, they can enforce the execution of binary at target instruction level with the interactive fraud proof. So the key observation here is that the interactive fraud proof verifier is enforcing the client execution logic. So it's actually for example, it's actually a guess compiled to WASM equivalence for the Aavechan. So and then we notice that the verifier is strongly coupled with a specific client binary. So next, I'm going to talk about the security and decentralized challenge based on this observation. So we actually found out that this observation is the root cause for the following challenges. So first, this architecture precludes permissionless, trust-minimized client diversity. And second, the trusted computing base of this architecture is very difficult to audit and even infeasible to formally verify. And third, there are a huge governance burden on frequently triggered upgrade process. So next, we are going to dive into these challenges. So about client diversity, so we don't want a single client to dominate the network because it limited defense against monoculture failure, and a bug in that a single client can bring down the entire network or cause invalid state transitions. So why this architecture precludes permissionless, trusted minimized client diversity? Because on-chain, the verifier is strongly coupled with a specific client. So imagine that you compile gas to Wasm and Aragon to Wasm. The two resulting binary are completely different, and their execution traces are very different. So if the verifier is enforcing the execution of gas, you cannot let Aragon to participate in the challenge. And maybe, so this is a solution, a partial solution proposed by Optimism is a K-majority scheme. So if we, instead of committing one binary, we're committing n binary to on-chain. And if there's a K of n majority clients pass the verification, then we say the fraud proof passed the verification. So does this scheme help? The answer is no. Because first, it is a permissioned client diversity. So you don't want a malicious attacker to submit arbitrary binary commitment on-chain, because it can allow the attacker to change the L2 semantics. So first, it is permission, and second, it is operationally complex, because all the validator needs to run all types of clients to participate in challenge. Since the execution trace of gas and Aragon are different, you cannot let them to do the interactive fraud proof and convince a single verifier that who is wrong and who is right. So the validator has to run all the nodes. And thirdly, it does not scale. So as we know, the current rollout clients consists of consensus layer clients and execution layer clients. But in this compiled approach, these two clients are compiled together. So for example, if we have 3 types of consensus layer clients and 3 types of execution layer clients, there are 9 combinations of the binary. So the operator has to maintain the 9 binary commitment on chain, and these validators need to run 9 different types of clients just for the challenge. So this is kind of unacceptable mitigation to the client diversity. So the second problem of this architecture is that the trusted computing base is too large, and parties must trust the correctness of the entire stack, including the client to implement the EVM correctly, and the compiler to compile it correctly, and also other components. Why the TCB includes the off-chain components? Because the off-chain components, like the off-chain clients, are committed on-chain. So this huge trusted computing base is difficult to audit, because you need to audit, for example, every changes to the gas client, every lines of the consensus clients, and also maybe the compiler or your make file to make sure, or the compiler options to make sure you are compiling correctly. So this TCB is difficult to audit and infeasible to formally verify, because once again, the TCB is too large. And the third problem is that it has governance burden on the frequently triggered upgrade process. So ideally, we want to ship ship the performance patch and the vulnerability patch of off-chain components without touching the on-chain components. But in this architecture, you cannot do so, because every off-chain component upgrade touches the TCB. And this put the L1 governance on the critical path. So if you change one line of gas code, maybe the compiled Watson binary or the MIPS binary is different, right? And the commitment of the binary will be different. So you have to upgrade the on-chain commitment. So this governance-dependent upgrade prevent the possibility of forfeiture of upgrade keys. So now we know the challenges in the current optimistic rollup. Let's talk about our solution to solve these challenges. So we know the root cause of these challenges are that there is a binary commitment that make the verifier coupled with a specific client. So we need to eliminate that binary commitment, right? So the observation we have is that we must decouple the protocol from the implementation. So to decouple them, the proof system must natively target a higher level L2 semantics instead of targeting a lower level VM semantics. So this semantics includes both consensus layer semantics and execution layer semantics. So more concretely, just like their approach, our solution also reuse the existing Ethereum clients on L2. However, we are going to design our interactive fraud proof system to enforce the EVM semantics directly instead of enforcing the Watson semantics with the binary commitment. So we are going to construct our one-step proof over EVM state transitions at EVM instruction level, so and also the consensus level state transitions. This architecture seems simple, but it has a lot of nice properties that solve the previously mentioned challenges one by one. So first, it has intrinsic client diversity. Because your verifier is not coupled with a specific client binary anymore, and so for example, on the execution layer, every client, despite they're different, maybe they're implemented differently or they are using a completely different programming language, they have to implement the EVM state transition exactly as the Ethereum specification, which is the yellow paper. So in this architecture, any clients that implements the EVM can be used to participate permissionlessly in the dispute resolution. And we only need to trust one of these are implemented correctly to make sure the network is secure. And also, in this architecture, it it has low operational complexity and scale with diversity. And the validator can run whatever node they want, and they only need to run one node. Second, this architecture has minimum and trustworthy TCB. And the TCB is only the on-chain verifier. The off-chain components are not in the TCB anymore. And this TCB, first, it is very small. It's just a smart contract, so it improves auditability. And also, it is formally verifiable because we have existing formal specifications of Ethereum, such as Daphne EVM or KEVM. We can use them to formally verify our TCB to make sure it is correct. And third, it has infrequent on-chain upgrades. So it only needs to be upgraded when the semantics change. Like, for example, when there is an Ethereum hub fork that adds a new opcode. And if you have performance improvements or vulnerability patch in the off-chain clients, and that, for example, you change the gas without touching the Ethereum semantics, you can, and these patches can be shipped without on-chain upgrade. So we claim that this architecture is practical to fulfill the upgrade key. So this is how we design the EVM native fraud-proof verifier. So basically, the verifier, when the dispute goes down to the one-step EVM instruction level, either defender or challenger partially reveals the EVM state to the verifier, so the verifier can simulate one EVM instruction on chain and compare the final EVM state with the assertion to decide the winner. So in order to partially verify the EVM, we design some data structures for different EVM components. Like for example, we Merkleized the memory. We use the hashing to model the stack. And as we all know, like the word state, like the storage or the account is already Merkleized by the Merkle patch tree. So in these data structures allow us to partially reveal the EVM state to make sure the verifier knows enough information to simulate one EVM instruction. So in Specular, we implement this interactive fraud verifier and also the prover and the peripheral features to make it a complete optimistic rollup. In the current implementation, we support all the semantics defined by the Ethereum spec, and we only modify 200 lines of code in gas to make it possible. Like in comparison, Optimism has 3,000 lines of changes, and Aavechan has even more. So in Specular, we have this design philosophy to guide our future directions of implementing the optimistic rollup. So on the security side, we want trust minimization. That is, a bug or exploit in one client software stack should have negligible impact of the system's overall security. And on the decentralized side, we want the credible neutrality. That is, a validator should be able to just in the case of Ethereum, operate permissionlessly, use any client software stacks existing or new of their choosing. So you are not limited to a single client that an optimistic rollup project provides. So before I go into the development updates, this is a takeaway chart for the previous sections. For Specular, we have minimal client modification. We have small TCB. We have intrinsic client diversity, and our upgrade is infrequent. So next is the development updates. Besides the novel EVM native interactive fraud proof, we also implement a client agnostic L1 to L2 message bridge, which does not require a new transaction type or any other further modification to the clients. So that's one reason why we can make our client changes so minimal. And also, we in the implementation, we demonstrate our practical client diversity. So when implementing the optimistic rollup, we decouple the consensus execution in a modular way in both normal operations and dispute resolution. And for execution layer diversity, beside the guess, we also implement the interactive fraud prover in Aragon. And in consensus layer diversity, we are trying to transiting to a new Rust-based client by extending a new Optimism's client called Maggie, which is built by A16Z. So, so that's the work we have done. And next, we are going to deploy our first testnet very soon, maybe end of September or starting the start of October. And we're also doing the formal verification of our TCB, which is the on-chain verifier. So we are verifying it against the existing formal spec called Daphne. So basically, we extract the semantics from the smart contract, and we compare it with that spec. And we're also doing the censorship resistance mechanism by force inclusion. So in the future, we want to explore a sequencer decentralization with MEV resistance. So we want this decentralization to be first permissionless, and also MEV resistance with like proposal builder separation like approach. Well, we want to improve the normal execution gas fee by introducing snark-friendly batch data compression, and we also want to improve the dispute resolution gas fee by maybe implementing the one-step proofing snark. And this is not conflict with the verifier we already implemented, because the snark is hard to formally verify. So we can maybe have two verifiers both on chain and let our current verifier to have higher priority because it can be formally verified. So that's my talk today. You can find us on Twitter and website, and feel free to reach out if you're a research or engineer interested in collaborating, or you are an application that is interested in participating in specular ecosystem. Thank you.
Thank you, Ya. We have about 5 minutes for questions. All right, if not, then we'll wrap it up there. Ya, thank you so much for your talk today, and we'll get started in about 5 minutes. All right, for our last talk of the day, we have Matt Gerbiel with Warp. Warp contracts are data-driven smart contracts on Arweave, crafted by Redstone. Give it up for Matt.
Hello, everyone. I know it's hot, I know it's late, so I'll try to keep it fairly compact. So my name is Matt. I lead BD for Redstone, which is mainly an Oracle provider, but we also do general infrastructure. And our second product is Warp Contract. So naturally, I'm also a contributor to Warp itself. And this presentation is going to give you like a brief intro to how you should think about EVM systems in comparison to Warp contracts and SmartWeave, so the framework of building smart contracts on top of Arweave, which is a data storage layer. I'll also quickly explain on why those sort of ecosystems are not competing against each other. They are fairly complementary, but I'll dive deeper into that in a second as well. So first, a bit of context. So obviously, a smart contract is a piece of code that you can run in a decentralized way. But when you look at the market of smart contract development right now, then you can see that it's fairly dominated by EVM, obviously, and the most prominent language of EVM, which is Solidity. But also when you look at the second place, well, the second place is taken by Viper, so another EVM-based language. So even though there is an increasing number of competitors joining this space, it's still very much dominated by EVM-based languages. But obviously, EVM does have its own sort of drawbacks that you have to keep in mind. So in general, it's fairly convenient to use it right now because everybody uses it, because the market penetration of it is so deep that you have a large database of knowledge, you have a shit ton of YouTube tutorials on how to use it. But when it comes to its important characteristics, what you have to sort of keep in mind is that it has a shared memory and shared state. So sharing that in general, it's not an easy task, but from the point of view of a developer, or from the point of view of smart contract execution, what you want to be doing is writing code and contracts that can access the whole space of that memory, because it's almost as if you were running a local process. But obviously, from the point of view of the network, it's not that easy, because what you have to do as a network is you have to, well, incentivize a lot of developers to keep a lot of data at hand at all times, because all of that data needs to be synchronized across thousands and thousands of nodes, which becomes increasingly expensive. That is why storage on EVM-based systems is super, super expensive. And to give you a bit of context for that, if you wanted to do an NFT the proper way, so instead of just storing the link to the content on-chain, if you wanted to store the content itself on-chain, let's say an image in the raw format directly in the chain storage, you'd have to pay around $100,000 just for one picture right now to get that on-chain. So you'd have to be probably out of your mind in order to do it. So that's how expensive storage is right now on EVM-based systems. And this is a huge limiting step if you want to build a data-heavy application on top of an EVM system. However, we have Arweave, and for those of you who don't know, Arweave is a data storage layer, so it's specifically designed to store large amounts of data indefinitely, or at least for 200 years. That is what the Arweave team guarantees right now based on the math. So basically indefinitely. And the most important thing about it is that it's a blockchain as well. So you have all of the security guarantees of a blockchain, including things like timestamp verification for the computation, or the strong guarantee of the persistence of that data you put on Arweave as long as the network still exists. And that is great. The storage capabilities of Arweave are great, but what if you want to build some logic on top of it? So what if you want to determine, okay, how do I get the data in Arweave? Or how do I get the data out? Or if you want to build like a real product or a business on top of it, then you have to use something that's called SmartWeave. And SmartWeave is basically a paradigm on evaluating the smart contract state that is
a bit different to what you see in the EVM-based ecosystems because it's based on the premise of something that's called lazy evaluation. So the data layer itself does not do any arbitrary computation itself. It leaves that out to the smart contract caller. So I don't want to calculate the state of the smart contract. I'll just leave that to the smart contract user, and that's why I'm lazy, hence the name lazy evaluation. So if you are the smart contract user, what you have to do is, in order to evaluate the state, you have to go through all of the interactions that all of the users on Arweave have ever done and basically calculate the state of that smart contract from the very, very beginning, from the moment of inception of that smart contract. That is how you do it. And so basically the way it works with SmartWeave, in other words, you just put the code out as a developer for people to use, then the users come in, they interact and calculate the state. All of those interactions are saved permanently on Arweave, and then the state can always be reevaluated based on those interactions. Now, what you have to do and know about SmartWeave is that it used to be not really usable back in the day, at least before Warp contracts, so the product we build at Redstone, came about. Because what we did was we basically took the philosophy of SmartWeave and just made it production ready and feature complete so that developers can really build and deploy smart contracts on Arweave. So what we are doing, that is basically the original idea behind SmartWeave, is we are just putting the code into the storage. So as a developer, you have a decentralized and trustless access to the code you're about to execute. And then we also decouple the execution of that code from the code itself. So why do we do it? Why do we do it? Because basically when you decouple both sides of this equation, you can really upgrade and optimize both of them independently. Okay? And this gives you a lot of flexibility in terms of things like the choice of language you'd like to use for that. So with Warp contract, we've gravitated towards JavaScript, which is basically, well, the baseline language for all web development currently. But obviously, it's not just vanilla JavaScript. We've done like a subset of it, just to make sure that everything we do with that JavaScript is deterministic, that every computation we do is safe and deterministic. But we are also big proponents of sort of bigger environments for doing these things, more environments that just make more sense, things like WASM or Rust specifically, just for you as a developer to have a bit more control over the costs and the complexity of the computation you're about to execute. So Warp contract currently is the most prominent and the most popular implementation of SmartWeave there is. So basically you could say it's the default way of building smart contracts on top of Arweave that's mainly focused on modularity, so that you can upgrade separate pieces of that system yourself. It's all open source, you can fork it as well. And if it comes to the most important parts of that system, well, you have the gateways, which are directly responsible for indexing the transactions on Arweave, so that we have the best possible view into what is the current state of that data network. We've got the sequencer as well. That is probably the most interesting part, because obviously sequencer, what it does is it just orders the transactions. You can also, as a user, you can send your transactions directly to the sequencer. And what we are going to do in the upcoming months is we are going to release a decentralized version of that sequencer that we were working on for the past 1 to 1.5 years. So it's going to be, a lot of work has already gone into that, so I think it's going to be a very robust kind of an implementation. So if you're interested in those kind of topics, decentralization of sequencers, then you should definitely follow us on Twitter, because more info on that will be coming up soon. We obviously have the WASM environment for deterministic execution, for you to have more control over the costs and complexity of that execution. We have the DRE nodes, which is a decentralized execution network, if you don't want to do the computation yourself, what you can do is just delegate that to the DRE nodes. What they do is just take the code, calculate the state, and give you back the results. And obviously, we also do have an SDK for developers to build smart contracts easily on top of Arweave. So the way it works operationally, when you look at the life cycle of a transaction, is it all starts with a sequencer, then it goes directly to our gateway, and the result of that is used by the executors to evaluate the state. You can do it either yourself with your own rules, or you can just delegate that to the DRE nodes. Now, so what's the business value behind all of this? What are the use cases that you can do with SmartWeave, but you can't really do with EVM-based systems? So let's take content once more as an example, and NFTs. So we got used to using NFTs on EVM-based chains. We got used to owning, trading them, and just having them in our wallets. But what we really do have in our pocket when we say we own an NFT is, well, just a derivative, right? A representation of the underlying content with no underlying content itself being stored on the chain. And that can be problematic, because what we see happening more and more often right now is those kind of zombie NFTs, where the content has already been deleted or whatever, the storage has expired. There is a bunch of different reasons that you can have behind it. So basically, there is just this empty shell derivative, but there is no underlying content beneath it. So an atomic NFT is basically a different kind of an asset, because it gives you a single place where you can store the content itself, as well as the logic for trading that token. So what you really own is the content itself as well, with that underlying logic. And what you trade is the same kind of a situation, the content plus the logic. So there is no possibility of the content evaporating suddenly. Going further, we have a lot of decentralized databases or database systems being built on top of Warp right now. So these are those systems that let you define, okay, how do I get the data in? How do I get the data out of Arweave? And do a whole bunch of stuff like indexing the data, formalizing it, processing it, whatever, you name it. These are protocols like WeaveDB, First Batch, and a couple of different very strong teams building right now on top of Warp for all the people that would like to build a permanent, decentralized, like truly decentralized database. AI, obviously we do see the boom in AI, but with that boom comes a lot of protocols that would like to build it in a truly decentralized and open way, not only calling themselves open AI, as some people do in the Silicon Valley. So what I mean by this is basically training the models in an open way, so you can see all the inputs, you can see all the calculations, you can check if there is any malicious or potentially malicious data involved in that whole process. And this is probably the way AI should be built in the future. Not sure if it will be built this way, but it's probably the way it should be built. So I just hope that those kind of solutions get more and more traction as we progress with the development of that sphere as well. So basically, those kinds of use cases are not even close to be possible on EVM-based systems, just because of the sheer volume of data that you have to process, and just because of the amount of computation that you have to do in order to make this work. So for these kinds of use cases, Warp is an enabler, and Arweave is the data storage layer as well. DataFi, so you can think of those sort of content markets the way you think about social graphs right now. It's a bit of a broader category than social graphs. But in general, these are the markets that can allow you to incentivize people to post content or reward content creators or content curators, actually, for what they do. And this sort of plugs in really well into my last slide today, which is going to be a little bit of a case study. So this is a real business use case that we've done with Lens protocol. You've probably heard about them. The biggest social graph to date, to my best knowledge. So basically what Lens does is they have a lot of interactions between users and the protocol. It's all based on Polygon as the underlying originating chain. But what Lens needs is first, they need to offload historical data of those interactions somewhere, and Arweave is definitely the place to do that, but it's fairly easy. It also goes through Warp. But what they also need to do is, to give you an example, let's take comments on Lens as an example here. So let's say you want to reward the person that comments you the most in the lifetime of your profile. So what you can also do, thanks to Arweave and Warp, you can just look at the historical data, retrieve it, and bridge it back to the originating chain, which is Polygon in that specific use case. So now this data is not only stored permanently, but it remains operational throughout its whole lifetime. So you can just bridge back the data package with what you've just calculated, and then just trigger the smart contracts of Lens protocol to reward the right people or do whatever you want to do with what you've just retrieved from Arweave. So there's many, many more of those use cases. We post a lot about them on our blog. And if you'd like to dive deeper into how that works specifically, then probably our website and our blog is going to be the best sort of place to start. So that's it from me for now. If there's any questions, just hit me up right now.
Yeah, we have about 5 minutes for questions. Right over here.
You shared a very interesting example about NFTs, with like that you can store the data permanently and have programmability of the NFTs and the interactions, essentially. Reminds me of some of the things that are currently built on Solana and are gaining traction. I was just wondering if you could maybe share some statistics of projects like that are already using this, and if it's gaining traction on Warp.
So I think I don't have the exact numbers on NFTs specifically, but just to give you like a benchmark on how that looks like. So if it comes to my best knowledge, protocols that have deployed something on production in general with Warp, it's about 35 teams in general. If it comes to, if you wanted to count all the GitHub commits, also those that are not yet deployed to production, that's around 80-ish protocols. So in general, the numbers are not like super big yet, but there is more and more big players coming like Lens protocol. And also, if it comes to Arweave and Solana, so I'm sure you know about Metaplex. So basically Arweave, I think it still is, if I'm not mistaken, is like the underlying storage layer for NFTs on Solana through Metaplex anyways. But yeah, if it comes to that specific use case, I'm not sure if somebody did that on production already on Arweave. Would have to double check that. But yeah, it's definitely an interesting use case. If you can do that on Solana, it's also great. I'd love to dive deeper into that. But in general, I just believe that this is probably the way you should do NFTs in general in the long run, just for it to make sense and just for it, to have like this historical almost value. Because I like to look at NFTs also as, as pieces of history. But if the underlying content is gone, then it's like, it's an empty shell. You don't really have that behind it. So super interesting use case, definitely.
Any other questions for Matt? All right, I think we'll wrap it up there. Thank you so much, Matt. And please join us out on the patio for happy hour. Cheers.